Go look at the stream. Yeah, no worries. Alright. Everything's good. Alright, check the stream real quick. Make sure everything's up. I'll check it. See if the camera's on right now. Okay. Alright, we're good to go, guys. I'm gonna get started today. Hey, my name's Adam El Kanufi. If y'all have been to some of our other events, y'all probably seen me already, or seen me like promoting like crazy around campus. But today is gonna be like our first big event of the year, like for the GDSC. You know, this is our first like 3-hour workshop where we're going through different topics, but we're also giving y'all the choice to come to what y'all want to learn, right? So hopefully y'all came here today to like learn a little bit about Git, and that's what I'm going to be hosting for y'all today. So today we're going to be talking about learning Git, right? And I like to call it like the class you wish you had, because they never teach it to you. You just got to kind of learn it on your own and you're screwed. Those are some core team members that were here to help us with this workshop for the Git. Olame is actually here with me right now. We have Jacob, who's actually sick and he couldn't make it, and we have Adam, who's like has some other responsibilities with class and coursework. Let's get started. I'm gonna pass it over to Olame. He's gonna get y'all started for today.
All right.
Try staying from the camera.
I know. So for today, we're gonna start with our agenda of the day. So we're gonna go through a couple things. We're gonna start by defining what is Git, so you're gonna have an idea exactly of what we'll be talking about today, and then how you can use that tool for your resume and your work, your developing project and everything like that. And then also we're gonna see how to install, how to configure as well, because we're gonna have a little bit of a workshop today. And also on top of that, also we're gonna do like we have a dummy repo up there, so you're gonna have to interact with it, push couple things, pull couple things. We're gonna come to the vocabulary a little bit later, and there will be also a trivia game after that. And after that, we have also a couple swags right here. We have a backpack, we have like a water bottle and a couple stickers right there. All right. So next, what is Git? So when we're talking about Git, it was something that was developed by Linux initially, and it's like a distributed version control system. So, and there you can see a picture of Linus Torvalds. That's the guy who created Linux OS. So he's like the backbone of the whole thing, Android and everything you've been looking at outside there. And then also, as I said, it was developed by Linux, and it was more for the patches, like when they're all working as a group. They were like, hey, we don't want to have just one thing centralized, keep coming here editing, and then somebody breaks the whole thing, we have to go through it again. So they were like, okay, everybody can work on their own things, and then put it out there and see how it works. If it breaks, you just take out the one you put it, and we'll be moving with it, right? So that's how they were doing patches. And after that, they saw like the popularity and everything like that. They were like, you know what? Let's put it out there, add more users, and try to make it move like a little bit better, so people can now use it out there. So next up, we're gonna talk about the benefit of Git. So you have a whole lot of benefit, but we're gonna focus on 5 of them, which are kind of the major ones, and those ones will be the fact that it's distributed, small and fast. You have the best branching model. You have that assurance as well, and also it's free and open source. So what do I mean by that? By distributed, you have the feature that every developers, every programmers should be able to pull, like the code. You have a code up there, you put it, you make a copy so you can work on it. So by pulling it, you have it on your local computer, which makes it faster, because you don't have to push every time somewhere. Like streaming, you know how streaming works, you have delays and everything like that. So you have everything on your local computer, work with it. When it's ready, just push it, and you have everything there, right? So that's when we come to the situation where it's small and fast, just because you're running it on your computer. And on top of that, it was programmed with C. So C is more like the language that has been, most of our operating system were written in C. So it's kind of easier to talk with like hardware and stuff. So it makes it like very, very, very fast, right? So on the next thing is the best branching model. So as I say, when you're working on your computer, you finish. Everybody got a copy of it. And what happened when you finish? You push it. So by pushing it, they have something they call the branching thing. And the branching comes like multiple people independent, like developers and programmers. They're all independent. They have their own copies, so they can work like frictionless. And also you have like the context switching, the role-based code, and also this possible experimentation. So for this possible experimentation, it's more like when you push something that didn't work. So you're like, hey guys, I just broke the whole code. So you can just dispose it, just the one branch you put it. So you just have to interact with your own part of the code. And on top of that, when you're putting something up there, you want it to be also nobody altered anything there. You don't want it to be compromised. You don't want to write something, and when you put it out there, it just changes like out of nowhere. So they have to encrypt everything. They have a whole algorithm that makes sure that everything you're putting in gets to the main repository all safe and not change it or tampered with, right? So after that, you're gonna have the free and open source. And what I love about it, as Linux also, it's open source. So the one reason I say that, Linux, if you realize, people will be like, hey, they don't say like Linux, you use Linux. So after that, the next question will be like, what distro are you using? So by the distros, it's more like all those flavors of Linux. So everybody can have a copy of the main Linux, and you make it your own. You customize it in a way that you want, and you can own it, and you can put it out there. People can start using it as well, right? So, and that's when you come to open source. The good thing is you don't have to pay for anything. And if you see a code out there, you like the way it works, you can read it, understand it. If you have a couple features you want to put on it, you can just go like, hey, you create a branch, you push it up there, and guess what? They're going to list you among all the contributors of that code, and that looks good on a resume as well, right? So after that, we're going to go through some terminologies. So they're more like definitions, so you don't hear like anything I'm going to say being like a jargon or something. It's more like just a dictionary. So you're going to have the repository, they're going to tell you what it is. So it's more like a reference thing, right? So merging, joining two things, like cloning, putting something, you put like a copy of it. So it's more like that, right? So after that, I'm gonna give it to Adam. So he's gonna go about the Git flows and everything, and explain you how exactly things work.
All right. Thank you, Alame. Just to touch on that Git terminology slide, we will be posting these on our Discord, so y'all are going to have access to our entire slide deck, which y'all will see has a lot of references like terminology, actual commands, and whatnot. But right now I'm going to be talking about the Git flow, and basically there's really two big parts of Git that's really important, and that's not only knowing what to type to do a certain action, but it's like how, right? And why. Like, why are we doing it? There's a certain pattern you need to do things when using Git. It's called the Git flow, right? It's the workflow. So this is more of a demo right here. We're not actually going to be typing this up, but this is like an example workflow where someone will start off by just initializing the Git repo locally, and then they'll try to make a README for it, so that way if others come onto their repo or clone it, they could see what the heck is on the repo. Next, they'll probably have to make a branch, and then you'll see here I called the branch dev because you'll never be posting updates to the actual main branch, and I'll get to that a little later. Lastly, people will add like a remote connection to their actual GitHub project, and that'll finalize and link not only your local machine but also your repo in the cloud. So that's what actually makes that link between both instances. And then this is the most basic way to commit, right? And there's two steps you need to know, which is first you need to stage your changes. So it's like telling Git, hey, I made changes to these files and I'm going to put them in this area. So this is called the staging area. Anything in that staging area means we have something that's changed. Now you can choose what you want to commit in the staging area. So for example, in git commit -m, all that's doing is it's pushing everything in your staging area onto the repo and like solidifying it. It's like saving it. However, if you wanted to commit a very specific part of the staging area, so not all your changes, you can like directly say, hey, I would like to use this staged code. I would like to commit specifically that. And at the bottom I have some simple commands like git log, git show, git diff, and I will get into those later about what they do, but they're very common and useful as well. And on the left, you can kind of see the diagram where we have the master, which is like GitHub. So when you type in www.github.com, that's what that cloud is referring to. And I put it in the cloud for a very specific reason, because that's what it is. It's a cloud-based platform, right? You're releasing your data where it was once locally, now it's no longer. And then, as you can see, I have develop. Now, I know I put like a little server room, and obviously I know y'all don't have servers in y'all's rooms, but in an enterprise fashion, right, that's where everything's going to be stored locally for that company, okay? But believe it or not, changes don't even happen there. Changes happen on the last slide, on the last part with the guy coding on the laptop. I called it the feature, and basically that's your normal developer like you and me who are going to code, make changes on these feature branches, and once they're done and completely functioning, then they push them to the developed branch, right? The cloud repo is strictly for production, right? That is supposed to always be functioning at all times. All right, the next one. So kind of like what I said earlier, you're never going to be committing to the origin, which is that cloud that we saw earlier in the other diagram, or your development branch. You don't want to commit directly to there. You're going to want to make branches for every little thing that you're going to want to add. So if you're like, okay, time to add a login feature for our website, right? You're going to create a whole new branch, and you're going to call it obviously something detailed like login page, and you're going to work on it. So here's like a very simple like flow of how someone would do that. They would go to their development branch, right? Then they would merge their feature branch into it, and then no FF is a flag, which I'll get into that later as well. And then they push that development branch back up into the origin. So you see that chain reaction where it's going from the feature branch to the development branch and then to the actual production branch, right? And then at the end, right there, that's for more or less if you're in a professional setting and you need to actually release versionized updates with version numbers, right? All they're doing is adding a tag to it. It's quite that simple. They just add a tag, and anytime you go on iOS and you see v1 point something, it's just a tag they added. So like on the top right, that's another cool diagram that I found that kind of shows how it's supposed to work, right? Let's go to the next one. Alright, now we're going to get into the types of workflows. right? Now this one I think is really important, like very important, because this is what they're going to be asking you in your internship interviews, your job interviews, because this is what they're going to use to benchmark your understanding of Git. So basically what you're going to be most likely running into, like in your 3380 or your 4330, is going to be what we call the subversion style workflow. And basically, even though we've been talking about Git as a decentralized version control system, you can still use a centralized workflow. And like in fact, it actually does it better. So if you see on the second bullet point, right, Git will never allow you to push if someone's pushed before you fetched. Now I'll get into like the actual terminology later, but basically Git has kind of like what Olame said, algorithms that will prevent you from doing centralized actions, right? So, but you can still make centralized workflows. So in this case, everyone's their own developer, everyone works on their own feature, and then y'all all push it into the shared repository, right? Usually these kind of repos are also private, because if they have access to the shared repo like that and it's not private, things could get a little dicey. So in the next one we have like the integration manager workflow, and this is what you're going to be seeing mostly in open source projects, right? So this is a decentralized workflow, as y'all can tell. Some of the developers never interact with, actually none of them do, interact with the blessed repository. That's what the picture called it. I don't know why they called it that. But basically this way there's a manager, right? There's one trusted individual. Usually in an open source project there's an inner core team of developers, and then they just let everyone join on board, right? So here you'll see that a lot of changes that people will make, they can never push it to the main branch. So what they'll have to do is they'll have to get it checked by the integration manager. Well, they have to look through the changes and whatnot, and then give you a pull request. And we'll get into that a little bit later as well. Here, this one's called the military workflow, and these names are very ambiguous. They can be replaced with anything basically, but so don't get too stuck on the wording. But this is another decentralized workflow, and this is what I honestly see more in terms of big tech companies and enterprises that have a lot of employees and a lot of developers, right? So they're not going to run it by just one person, because that would be way too much of a bottleneck. And then if you think of a company like, let's say, Google, which is huge, right? They're not going to have one guy that can check everything and give pull requests to everyone. It's impossible. So here they kind of use this military style of like ranking, right? And you'll see, and as you're looking through internships and jobs, you'll see senior, entry, junior 1, junior 2, etc., right? A lot of that comes from like their, I would say, like very loosely, permissions within the workflow of their like development cycle. So like in this example specifically, all developers pull from the repo, but then they pass their code to a lieutenant, and then if the lieutenant agrees with the code, he then passes it to the dictator, which then makes the final decision on whether or not a change should be added. Alright, get to the next one. So we're actually about to get started with like our actual workshop portion. So 90%, not even 90, 99% of devices, you buy them from the store, they'll have Git pre-installed, right? But just in case, right now I'd highly recommend going into your terminal and just typing in that command that, even though it's under Linux and Mac, you can type that into both. I've actually just come to find out, just git -- version. And if you don't have Git, I'd actually like you to raise your hand, because I'd probably have to like give you some guidance. So does anyone here not have Git by any chance? Alright, I'll let y'all figure out like as we go. If y'all don't, we could figure out later. So for those of y'all who have never used Git on your device, you're going to have to configure, right? So over here, they have git config, global user.name, and then your username. And then it's the same for the email. Now what happens is this is how they're going to connect your Git, which is on your local machine, to your actual GitHub account that you made, which I should backtrack a little bit. Everyone has a GitHub account, right? Okay. It's pretty simple to make as well. It's like making a Google account. And those are some simple commands to update. I'm using Mac, like Git 2.3. The versions don't really differ that much, but it's recommended that if you are, I think, below 2.1, that you should update. So if you just did git version and you have git and your version is like before 2.1, I'd highly recommend using one of those commands to update. Alright, I'm going to get started with the git workshop. Alright, so I call this the spooky terminal, right? This is what everyone's deathly afraid of. And like they see it and they gag and they try to find any other alternative that they can to do the same thing. And believe it or not, some of y'all actually might have already ran across some alternatives like GitHub Desktop. Even Visual Studio Code has extensions for GitHub. They're very useful, like extremely useful. However, you don't want to limit yourself, right? Our goal here is to build on skills that we have, and if you can expand that skill set any way possible, take that chance, right? Do it, because it'll make you very marketable. So here we have the spooky terminal. Let's get into it. So I'm going to be kind of walking y'all through it. Just that's kind of how we have our setup right now, because we're also doing this hybrid. A lot of people who've RSVP'd are currently watching us live. So just to keep it like a good balance, we're doing it this way. But to start off, I'd like for y'all to like clone our GDSC repo, and you should see that it'll give you a successful message after. You know what? I'm actually can keep that on there. I actually have an idea. Yeah, that's okay. Shoot. No, it's okay. Fine, we'll go back. You still have that weird terminal installed, Nick? Yeah. Alright, did everyone clone the repo? Did that go successfully? It should have worked for everyone. We have it public and everything. Alright, so next, the slides, so we don't have them right now posted. Yeah, it's okay, we're going to post them after. Actually, you can probably send out a link to it. Yeah, we'll post them right now. If y'all can go pull them up, we can do that too. Yeah, if you're in our Discord, I'll drop them in the Alright, so now that you have the repo cloned onto your device, you actually need to enter the repo. Right? And when I say enter the repo, in reality it's called your working directory, right? That's the directory you're going to be doing all your work in, all your git commands in. So you're just going to be CDing into that. That's the name of our workshop. Alright. And then once you're there, let's try to create two new files. We're going to call them alice.txt and then bob.txt. And let's just see where we can go from there. And kind of like what I've talked about earlier in the slides, what do y'all remember this being, like in the bottom two? This is how you commit, right? It's like that two-style workflow. First you stage them, and then you commit them. And what's really nice, as y'all can tell, I'm staging multiple things at once. I'm staging alice.txt and bob.txt. Now y'all come to realize this as we'll go on, but I'll kind of tell y'all now. There's a lot of different ways to do the same thing in Git. And I actually kind of really like that redundancy, because you can never go wrong whenever you're looking up like for help. If you're on Google trying to find a solution, you can find 5 different solutions that all do the same thing. So this is one way for you to stage and commit a file, and you could even stage multiple files. Has everyone committed both those 2 new files? Okay, good. It's going to get a little harder, at least I think. Alright, let's see. So now we're going to use that function that I had showed y'all earlier, which is git log, right? And we're also going to be talking about git show and git diff. So now I'm going to talk about basically the benefits of these 3 commands. So git log, you should be able to see what just happened to the repo. And not only that, I want y'all to see, because I accidentally, whenever I was making this workshop, I actually ran into this on accident, and I was like, wow, that's actually neat. But does anyone know specifically like what the git log outputs? Can anyone tell me? Basically, right, I had thought that git log is only supposed to show the git, like any type of git commands that you've run recently on your repo, but actually it shows all the logs for that specific repo. So now that y'all cloned it and y'all git log, y'all should be seeing a lot of rage messages from me, like past commits of me trying to get this workshop to work. Yeah, so that's what that's for. It's really useful for like tracking stuff. Now we have our git show. which allows you to show more info about a specific commit that you just made. And let's say you don't want to access the most recent commit. You want to access a specific commit from like 8 commits ago, right? All you have to do, use git log, find the commit ID, which should be like a long hash number, and then just put that right after show. And it will show you details about that very specific commit, like in-depth details. Alright? Now that we've gotten to that, I'd like for y'all to like open alice.txt, right? Now y'all can literally just go into your file system. You don't have to open up VS Code or nothing like that. Just go into your file system, open up the folder, and then like open up alice.txt. And then instead of whatever's in there, which is probably nothing because y'all just made it, try to write your favorite quote or song lyric or something, right? Like something funny or something. I don't know. I'll leave it up to y'all. Alright. And then after y'all change that, make sure you save the file. Because if you don't save any file, it'll never, like Git will never recognize that it was changed. So you save the file, and then run git diff. And then tell me what pops up. Or y'all could probably see the difference between alice.txt before and then now that y'all have added something into it, right? Is that what everyone sees? Let's see. Yeah. That's why I said it's probably better for me to do it in the terminal.
What's wrong with you?
He downloaded some. You could still do it in that terminal. It was an eyesore. Alright. So in git diff, you should be able to see, like I said, the before when the file is empty and the after. By the way, if any of y'all are running into issues and y'all are stuck with something, please raise your hand. You know, I'm happy to help.
I don't really get it.
Okay, so are you in your terminal right now?
Yeah.
So type in git, G-I-T, and then a space, and then dash, like hyphen, version. Okay. Alright, so, well, no, do you have Homebrew? Have you ever used that? What's the Homebrew? Is the Homebrew dash version? Try a Homebrew.
Brew dash version.
Yeah. Excuse me? Yeah. Excuse me?
Flex is not recognized as a name. It will only use Flex.
Are you on Mac or
I'm on Windows.
you're on Windows? Okay. No, yeah. So touch is actually touch is a Linux and Mac-based specific command. So let me think. All we're doing there is creating the README file. So in all actuality, if you want to replicate that, you just got to go in your file system, click New, and then add the file. And if it turns out that you don't end up having Git installed, you can find the installation on the Git pages. Yeah? Yeah, I didn't really quite think of a touch command. Because I don't use much commands that aren't Git commands. So like that one flew under my radar. Yeah. Try it. Save it for the end then. Alright. I'm going to go on to the next slide. Like I said, if y'all have any issues, raise your hand and we'll try to get someone to help you. Yeah. So I'll go back to that. So as soon as you clone the repo, right, it will go to a specific location. Usually if you're cloning it like from your home screen, it'll go straight into like your desktop sometimes. And then all you'd have to do is move into your working directory. So here it's CD. I believe in Windows it's the same.
Yeah.
It is the same, yeah. So if you do CD git workshop, it should bring you right into the workshop, because wherever you cloned it, right, it should make git workshop right there as well. So you should be able to CD right into it.
It should make that in the directory and the CD puts you inside there. Yeah, I was just trying to find it like
Oh, okay.
Are you using PowerPoint or are you using I'm using PowerPoint. Yeah, I know PowerPoint. Maybe just I should probably use I don't like the PowerPoint.
Yeah, I wouldn't recommend PowerShell either. PowerShell is more for scripting and stuff.
I like the good one.
Yeah.
I'll do it.
All right. Here. Let's move forward a little bit. So basically, once you use that last command, git diff, as you can see, you can probably see how helpful it is. It basically tells you like, hey, what's the differences that just occurred between these last two commits? And it'll tell you. So now that you opened alice.txt and you edited it, you added some text, and you used git diff to check like, hey, what's different? Try using the commands we learned to stage and commit these files. Right? So there's a very specific like two-step thing to do to commit your files. Right? We have to stage and then we have to commit. Alright, as y'all can see in the bottom right here, if y'all forgot, if y'all are going to want to stage and commit something, that's exactly how you're going to do it. You're going to add it first, that adds it to the staging area, like I said earlier, and then you're going to commit it with a message. A message is required, so you got to put it, and also, even if it wasn't required, very highly recommended, right? You don't want to have just random updates. Alright, so did everyone stage and commit that file? Their new alice.txt? Okay, good. Alright, so now you can use git status to check what's in your staging area. So, using git status is actually really helpful. It's one of the most helpful commands in my opinion, because sometimes, especially when you're working the command line and not like VS Code, so VS Code, right, it's like a GUI. It literally puts it in a hierarchy for you so you can see every file in your staging area. However, in the command line, you're not given, you know, that benefit. So you're going to have to use git status a lot to be able to look what's in my staging area, what's new in my staging area, what's changed in my staging area. Alright? So I set up this fake situation, right? Let's say you changed your mind, right? You didn't like what you put into alice.txt. You know, that was a lame joke anyway. So you can use reset, right? And what this is doing is it's resetting the head of Alex. So if y'all are familiar with like C and pointers and stuff, in a way it's kind of like that. Alice.txt, whenever you update it, you now moved its head, right? So now its current version is that new version you just added. So what this is doing is you're resetting the head. You're now removing that head to go back and revert back to the previous version of Alice. Did git reset head alice.txt work for people? Okay, good. Alright, now check the status again, right? How's it different? So we just checked the staging area, and it should have been empty. Now we reset alice.txt. Now let's check our staging area again. Okay, now once you reset the head of alice.txt, to completely finalize the reversion, to go back to the completely empty state that you found alice.txt when you made it, you finish it off with git checkout alice.txt. Now what's that going to do is it's going to check out the alice.txt file, and it's going to bring it back, like it's going to solidify the head that you had just set, right? So you just reset its head, and then git checking out is solidifying it. And once y'all do those two commands, I want y'all to open alice.txt and tell me what y'all see in there. Hint, it should be empty. Yeah? It's not? Okay. Did you do git status? Alright. And what does it say is in your staging area? Yeah? So, okay, so I know it kind of was confusing. It kind of seemed like they're two different things, which they are, two different things. But it's kind of like the git add and the git commit. It's in a sequence, right? So git adds one thing, git commits one thing. But however, you can't commit without adding it to the staging area first. So it's like that. We're resetting the head, and then we check out of the file and we solidify it. That's staging in a way, right? And you'll see that checkout, you use it for a lot of things, not just files, for branches and for other ones. That's kind of like your main command, like, hey, back out of it. Stuff.
So it says that the head of work is like untracked files.
Okay. Okay. I'm gonna come check it out real quick. What it's doing is one of the last things. So if you actually do it twice, there's a good chance that it's only going to your last command. Or if you do so once to go to the Alright guys, All right. Oops. All right. So now we're gonna get into like the main part of Git, right? Like the reasoning for Git being so popular, right? Which is its branching and merging abilities. So let's create a branch, and I want it to be, your name, and I have a reason for it later. I'll tell y'all. So to create a branch, there's actually multiple ways you can create a branch, but this way right here, git checkout -b, what it's doing is it's not only going into a branch, it's saying, hey, the -b flag is saying, if there isn't a branch already made with this name, create it and then enter it. So that's what that's doing. So once you do that, you should just be put onto the next line. Is everyone there? Okay. So to check what branch you're on and to list the rest, simple command, git branch, that's it. You'll see an asterisk right next to the branch that you're on. And then you'll see a list of the other branches. Right? So does everyone see that? I think right now you should see your name with the asterisk because you're in it. And then you should also see the origin one. Okay. So another file that we had pre-disposition, like pre-placed in the repo, was a file called secret.txt. So in there, it's a little knock-knock joke, like it has a Google reference. But basically, what I want y'all to do is, make it into a better joke or whatever, change it. And now I'm going to show y'all a cool little trick. So after y'all edit secret.txt and y'all are going to stage and commit it, right? You can do the basic way that we've been going over, which is adding it to the staging area first and then committing it. So it starts off with this first part right here. But you can streamline the whole command, and that's why I was saying I really love the redundancy of Git, because you could get away with doing multiple different things and still having the same outcome. But here, what I'm saying here with these flags is I'm committing, but first I would like to add it to the staging area. That's what the -a is for. So git commit -a and then m is not only gonna stage it for you, it's gonna commit it with a message as well. So you're doing that two-punch combo in once. I'm gonna wait till we get some commits going. Yeah? You got a question? Yeah. Not right now, there isn't any, but just in general. Oh, like him. No. Oh. Them is so lame. I hate them so much. Nano's a lot better, but it's whatever. I'm sorry. You could try it again. People who like them are obsessed with them. That's all I'll say. I'll leave it at that, right? Yeah. I like Nano, but really, if y'all really want to simplify all of this, just open up the file in your file system, and it'll prompt up a little text, and you could edit it like that. You should do that. All right. how's everyone at with this branch and with their new committed secret, right? Y'all made some changes to it, I hope? Alright, good. Is everything good on this end as well? Y'all managed to change secret and commit it? Okay. Okay. Well, what are you trying to do on Xcode, if you don't mind? Well, what? Here's what's happening. Xcode. Okay. So I'll get started, guys, with the next part. So, time to break things, guys. Now this is. Oh, I don't know why it's like that. Okay, whatever. It's not like that on my screen, but basically, whenever you're going to be merging branches together, whether it's with your main branch, your development branch, whatever, right? It could look something like this. Conflict. Awful. You want that. I mean, you don't want that. And then, oops. And then we're going to fix them. Okay, merge conflict resolve. We're going to try to resolve the merge conflicts. So, to get started, to keep us on the good habit of not interacting with main, that's what we're not going to do. We're not going to be interacting with main, okay? Because that's what you're going to be doing in the real world as well. So we're going to create a new branch. And this time, this branch is going to be called conflict. Obviously, we're going to be using this branch to like make our own conflict, like forcefully. Now, if y'all can see, y'all are probably a little thrown off with the command that I have at the top for making a new branch, which is git switch -c conflict. Now, this is just me playing around with y'all, trying to mess with y'all's heads, because I want y'all to realize like the redundancy could be a good thing, right? So we already made a branch in the past with git checkout -b, right? But you can also use git switch -c conflict, which basically what this is saying, the git switch command just switches your branches. And the -c flag is saying, hey, if this branch doesn't exist, create it. So it's kind of like the other one, does the same thing. And it also switches you into it immediately. And it should say it. Does it prompt like you've switched into this branch? Good, good. Alright, now, I don't actually have this command up here, but I'd like y'all to do it just to triple check. But run git branch one more time, and make sure the asterisk is next to conflict. Make sure you're in the conflict branch. Is everyone in the conflict branch right now? You in the conflict branch? Okay. Everything's good? Okay. So, now that you're in the conflict branch, and you're sure that you're in the conflict branch, we're going to edit the secret.txt again. Now, whenever you go to open it, you'll notice it's not going to have the changes you just committed to your previous branch. It's going to have the lame Google joke that I put in there. Right? And what's happening is, now that you've switched branches, Git is automatically switching the version of the file. Right? Because the version on that branch is different. I said put the name of your favorite movie. You can put whatever you want. Doesn't matter. Just make sure whatever you put is different than what you're putting in your first branch. That's a key part of this. We're trying to create a conflict. So whatever you added to secret on the first branch with your name, make sure the secret in the conflict branch is different. Alright? Now, let's actually compare the conflict branch to your branch. So right now, you should be still on the conflict branch after you edited the secret. And I also didn't add on there, but you should stage and commit as well. Or actually, I'll lie. That's coming up. My bad. So now to compare, you just use git diff. But this time, instead of comparing the commits, you want to compare your branch to an entirely different branch. So you're going to do git diff, and then you're going to put the name of your branch. Okay? And it should show you the differences between them. And then one big difference should be the secret file. Does it spot that for y'all? The differences between the two secret files? Alright, good. So, we're going to want to move back into our branch, right? The branch with your name on it. And we're going to change the secret again. One more time. We're going to change it to 7-digit code. Or whatever you want. Doesn't really matter. The reason why I'm doing a lot of this, like changing the same file over and over, is because, believe it or not, Git is actually that good. Is that if you try to make a conflict too simple, Git will automatically resolve it for you. And like while I was working on this workshop, I really wanted to force a conflict for y'all to resolve, and I was getting mad because like it would not conflict. It would just resolve it automatically for me. And I was like, no, I don't want that. Stop helping me. So that's why I'm being repetitive with this. So move back into your branch, change the secret, and then commit it. And you can stage and commit it at the same time with the flags AM, right? M is for leaving the message, A is for adding it to the staging area. Alright? Has everyone staged and committed their new secret to their branch? Okay, good. So right now, if you type git branch, you should be in your branch with your name. The asterisk should be right next to that. Alright. Now let's create a conflict. Now, there is no command like merge conflict. Our branch is just named conflict. I just wanted to clarify that. I didn't really realize that could have been kind of confusing. But time to create the merge conflict. So now that you're back in your branch, you should be able to merge the conflict branch with a different secret into yours, right? And now I want y'all to tell me what pops up for y'all when y'all do that. You got a merge conflict? Perfect. I was worried some of y'all actually, it might get automatically resolved. What about y'all? Conflict? Huh? Okay, perfect, yeah. That's what we want. So the conflict's there. Got me worried for a second, man. So, you got a question, Bud?
Oh yeah, so I'm trying to figure out.
Okay, that's fine. So, now we're going to try to resolve this conflict so we can dance like that guy in the meme earlier. So, what it's prompting you to do is like, hey, you got a conflict, you got to go make a decision. You either want to keep the version of secret that's on conflict, or you want to keep the version that's on your branch right now, or you could even just scratch both changes and then change it to one more like solidified change, right? Now, to do that, y'all can open up the secret one more time, right? Don't do that command right away, right? Open up the secret file, right? And I want y'all to tell me what it says. It should look different. It should have added some stuff you definitely didn't do. Yeah? I'll get to that right after the workshop. Okay. Because there it is. No, not hardware resources. Okay. What does it look like? Y'all see that where it says head and flips it for y'all? Perfect. So, with this branch now, when you open up your text file, you should be able to see both versions. Kind of like what I said before, now you got to make a decision. So remove one of them and remove the arrows that say head and the arrows that say your branch. Remove those two. You don't want to save that, right? So remove everything that you don't want to keep. Only keep what you want to keep. And then once you're done with that, you can add it to the staging area and then commit it. So you could do it that way, or you could do it the git commit -am, right? And then leave a message saying you resolved the merge conflict. Alright? Now that you've committed and you resolved the merge and now you're done, this is what's going to be expected in industry. I definitely didn't do this in my 3380 class, but because like you should see our repo. It's like tons of branches that we just never deleted. But whenever you're done with a feature and you successfully added it to the development branch, remember how we split it up? You got your repo on GitHub in the cloud, you have the development branch, and then you have your feature branch. Once your feature branch is done and you merged it into the development branch, now you remove the feature branch. So you can delete it by doing git branch -d and then type in the name of the branch, conflict. What does it say? It work for y'all? Perfect. All right. So basically, I'm just going to go through the bullet points real quick. What you learned today: cloning repositories, staging and committing files, checking the status of your repo, checking differences in branches and files, reverting or undoing changes, even though I know some of y'all had some complications with that one. Reverting is probably, in my opinion, the hardest thing to do in Git. Like, more than branching and merging, it's like reverting, worst thing ever. Branching and merging, and then also fixing merge conflicts. And then lastly, this is why I had y'all put y'all's name on there. If y'all would like to be a contributor to this workshop that we had tonight, all you have to do is then type in, make sure you're in your branch, I believe. Actually, I lie. I don't think you have to be in your branch. But just to be safe, be in your branch. And then do git push -u origin. And what that is saying is the -u is saying I want to push a branch into origin. Whereas if you just did git push origin, you would push all your changes onto origin, right? And we don't want that. We just want you to add your branch in. Okay? Because then if that's the case, we're going to have like 100 different versions of secret.txt. So git push -u origin, and then put your name, your branch name. And what does it say? Should have gave y'all a message, I believe. And actually, I can do this. Just to see who's been like keeping up, we can do this. Huh? Let's see how many branches. I don't know. Of you all. Oh. Okay. That's weird. Git push it to the, because I tested it. That's why you saw my branch, Adam E. Whenever y'all push y'all's branch onto there, I actually don't know if it'll happen instantaneously. I just tried to check our repo to see if y'all's branches were there. They're not there right now, but did y'all do it? It worked successfully, that command? Oh, it didn't let you push it? Whenever you configure, that's kind of like whenever I was talking about the installation and configuration page, highly recommend configure your Git first. Put your username, put your email. That way, whenever you try to do any actions, your GitHub account's already linked. So there's no type of worry for that. Yeah, you always have to do that at any time and it would work. Should we try to come back for the Kahoot? What do y'all think?
Yeah, we'll come back.
Do it quick or come back?
Come back like when.
Alright. Alright guys.
At the end you have a
We'll do a Kahoot. Why not? Do a Kahoot. This is for our swag up here for today. So I'm sure most of y'all use Kahoot. It's not insanely hard or something. You remember how I did it for you, Nick?
No, you
both my
set it up on your computer.
Both of my computers are super slow. I don't get it. Mine's the same way. Dude, edge on? Wow, did Kahoot go down? I think Kahoot's down. We can do the slides. The questions are... Oh, I deleted them. No way. Ah, it's whatever. Whatever. Let's try to get it running later, because we had 6 o'clock coming up. All right. The Kahoot's not gonna work right now. I know that this swag giveaway I was gonna do like specifically for Git, like it's all Git questions, so it's gonna be weird bringing it up later. But I will bring it up later because we kind of have to. Yeah, our odds Kahoot servers are down, so yeah.
Wait.
Continue as guest. Continue as guest. We don't need to save it.
I'm clicking it.
Yeah, it's down. Oof. It's okay, guys. One last thing. We're gonna share these slides. If they actually, I think Nick already shared them.
They should be in our Discord.
Let me show them this. So over here, we made at the very end of our slide deck, kind of like a simple little cheat sheet. It's basically kind of going over what we went through, like command-wise, and then also giving you more flags and parameters. Because I've touched like the tip of the iceberg when it comes to flags and parameters. Like there's tons. And all it takes is going to Git's pages. You literally type www.git.com, and it'll bring you straight to their man pages where you see all their commands. Like to this day, I don't remember what flag to use. I'm like, okay, what flag do I use to resolve a merge conflict as fast as possible? And it's -no-ff, which is fast forward. Or that's no fast forward, sorry. So -ff would be fast forward. But basically, you can find all that there.
Yeah, and if you're ever in a bind and can't remember a command just like this, in your terminal, just man git, enter all the information you could probably ever ask for related to Git right here.
Alright, I'm gonna get Rohan up. Hey Rohan. Oh, you're in the Zoom. You could share your screen if you would like.
Has the workshop started?
You could share your screen, Rohan.
Has the workshop started?
Yeah, we just finished up the Git presentation and we're just about ready to get started with React.
Cool. So it's not being shared right now, right?
I could stop sharing it. Whenever Rohan's ready. Hey Rohan, you just tell us when you're ready. We'll share your screen.
Nice. So, I mean, first, I don't have to speak, right? So,
Yeah.
5 minutes. I'm ready for now.
Okay.
Don't share my screen. Like, when I'm going on, then would you please share?
Okay. Perfect.
Thanks.
So slow my computer is.
Looks like it goes thousand. You gotta do this on the other page. What can we say? We know what we like.
Whenever you're ready, partner.
Alright, welcome to the React workshop everyone. So today we are going to discuss the basics we require for React and how to build a React project, and in the end we'll be building a React project called Go Riders app uh, with Rohan. Me and Rohan will be working on this workshop. Okay, so how many of you use Instagram, Facebook, WhatsApp, Discord? You know an interesting fact about them? They are all built by using React. React is actually developed by Facebook in 2013 using JavaScript. React is a JavaScript framework developed by Facebook. Uh, so all these major famous apps, they all use React. Alright. So what are the prerequisites for React? So it's just basically basic HTML and JavaScript. That's all you need to start with React, and some CSS. How do you start with a React project exactly? So there are some commands. There are some commands on terminal which you use to create a React project. They are like npx create React app and your app name. This creates you a React project in your selected folder. And after that, you should run a command called npm install. This command basically installs all your node dependency packages to run the React program. And npm start, after you install all these, if you hit npm start, all the packages are getting compiled and your project is visible on the browser. And that's it. You'll have your first React app. And so in today's app, which we are going to build, we use actually Firebase as a backend. Firebase is a service provided by Google. So Firebase is like developed using a NoSQL language. It's a database. And also we use Firebase auth. Whenever you see, if you were logging into some app, there is always an option: sign in with Google and sign in with Facebook, without any requirement for you to create a new sign up option in that app. That is done by using Firebase auth. So where do you exactly use the React and Firebase in your school? It's basically it's used in your project classes like Object-Oriented Design 3380 and Software Systems Programming 4330. I would encourage, if you are a front end freak, like you only know front end, not the back end, you can use React as your front end framework, and all the back end is uh, done by Firebase. Any questions? So Rohan will be leading the development of the Riders app. Here's a small screenshot.
All right, Rohan, we are ready whenever you are.
Right. Perfect.
Does he have a camera? I don't see a camera. Oh, it's over here on my other monitor. Okay. You see where he's at? In his picture? Wait, I need a pen.
Can you see us, Rohan?
I can, thanks.
Okay.
He's ready to go. You're ready, Rohan, whenever you are.
Alright. Thanks. So, let's begin. So hi, I'm Rohan. I'm going to show a quick, well, not quick, it's about 15 minutes or so, they have to build an app together. You could follow along if you'd like, so you should have React installed. So, we're going to use Create React App, as Praveen might have mentioned. So, if you have that set up, and we have like Node and all, like all the basic web set up, it would go long, or else you would now if you learn some React from here, or you at least get some React from here, you could head over to our repo. So it's on our GDSC LSU GitHub page, and React Beginner Right Sharing App. So I'm sure some of you go team will share this link. And yeah, so there are so looks like we haven't pushed all the branches, but that's fine, and we'll see all the steps. So after workshop we'll be able to see it. If you want to check the sample, you can just head over to our sample website, and it will look something like this. So again, this is on React Beginner Right Sharing App with GDSC.com. So you'll see, so since we're trying to make it like a right sharing app, so you have two sections, one is for driver, one is for rider. So the driver is able to see all the riders. So here's Michelle Anderson and the LSU ID or something. And the space is training. They want to go from the LSU TTC to the Nicholson hub. And so the driver can change the state of these, so they can drop down, and so on and so forth. There are three other riders. So this is the driver section. The driver section, you could actually create, you could submit a ride request that the driver can look at. Now, this is just a demo application, so of course the driver and the rider would be two separate screens. If we actually build this like a real application, but since it is from a demo, you can actually create your drivers either in the driver section and then immediately create in the driver section. So, cool. Let's begin. So, again, if you'd like to follow along, you could just close this repository. And so actually, this is a good promotion of our previous workshop, which we were seeing how to clone, which I'm sure they covered. So you could copy this link and head over to whichever folder you want to clone to. So I've already cloned one. Just click clone and then use this link. And if you don't want to follow along, make sure you save this link here, which is our dev app, since you're going to actually make changes to this and have the changes seen on our presentation in real time. And that's where the 5 weeks integration comes in. So, cool. Let's begin. So this app, or this project is divided into multiple steps. So there are 9 steps. And so each step has its own starter and solution code. So that you could follow along. If you need help, you can get the solution for that step. So yeah, along those lines. So first step is to create a header, and yeah, we're gonna scroll through these as we build those. So without any further ado, let's begin. So yeah, I will just push this. So first we need to check out to our step 1 starter code branch. you have to run npm r as Varun just mentioned. Or you could run npm install. This will install all the dependencies that are mentioned in those files that are mentioned in your graph.json file. So this is like defining what all the dependencies and what's the name of the package and version number. So all this information is inside of JSON. So all these dependencies are there. So running npm I installs those dependencies. Cool. So now that that's done, let's run npm run start. You can also run npm start. They're both into the same thing. Oh, this is another taskbar to be done. Let me close this. Yes, that's right. Npm start. And just push these branches that I believe aren't pushed right now. So yeah, you could take away all of these also. Yeah, and alright, I'll just do this very quickly. So again, this is actually a refresher. Then you have some local work that you haven't put. It's not visible for everyone else, and so that's what we're doing. We have a lot of this local work, so we're just pushing it so that we can pull it on your own. Yeah, so as I mentioned, divided into multiple steps as well as so many branches, and you notice that each step has its starter and solution code. So, yeah. If you have just two more, or three more steps, and then we should be done. Please. We just have one more, and then I promise you, we're going to get on to the workflow. And then last one. Alright, so we start with a blank screen. So as Brendan mentioned, this workshop is also going to focus on the React stuff. So the CSS style has been done. So you don't have to worry about CSS. Ideally, if you have a little bit of development experience, just in very little bit, you need to know like what's HTML. That's just about it. You at least have some understanding of what you're doing. So, yes, styles are done, and let us head over to our first to do. So, so our first to do here is to create a state variable called user. So, in React, whenever you create a state variable, you use the use state code. So I'll just create users and separate it. Yeah, dot use state. So this is a very common way of you don't use this a lot because you don't have variables that will affect the UI. So this is the way you define a state variable. So user is a variable, and to change it, you have this constant here. And since this is TypeScript, which you can just ignore for now, you can specify a type. Because so this user is like this is standing or not. So the user could be there, or the user could be null if the user is not standing. And inside the app, let us add a header property. So the header, it expects a user, so let us pass these props down. And again, what is a prop? Just think of it as a parameter. So this you can think of this what we have here as a function call, and you can think of these things as a parameter. So it's like how in a function say a function name, and then you have these calls and these parameters here. So a component is you get into just a regular JavaScript function that returns kind of like an HTML tag. But technically it's a thing called GDSC, but we're not going to keep making it confusing today. You just think of it as a function. You see, this is a function that returns just like an HTML looking thing. So that's all that React is. So yeah, let's fix errors here. Alright. It's just some TypeScript stuff that you can we'll just ignore this one. Alright, so we have added our header, and we should be let's take a look, go here. Yeah, I'm not sure what this error is, but let's just ignore this for now. So yeah, let's start coding our header. So if you go to our header component, so we have created multiple components here. We have this header tag, and let's start adding our stuff. So if we take a look at our finished version, we want something on the left, and we want something on the right. So yeah, let's start coding this. So inside the header, let us create two loops. One is for the left, it is for the left, and then the other one is for the right. Yeah, left and right. So that is for left, push and this right portion. And let us add on the left and one button on the right. So as you can see, like in React, all that you're doing is like having a function header that's returning some basic stuff. So yeah, all it's facing here is if you know HTML behind it, you know it's just portion of React concept. So the first portion is code diagrams or code lines, and then there's a tiger element. And on the next one, and this one says write share app for LSC titles. And let's add some class names. So in HTML we would say class is equal to something, but in React we would say class name with the camel face. So that's just a different way of doing things in React. So we need this subtitle. Now, this is like, why are we using this? That's because we have CSS styles pre-built for us. So if you notice that we have some styles for title and subtitle. So that's why I'm just following what a people says, just name it title and subtitle. So yeah, you can name it anything. It's not a requirement, but if you want those styles, you can name it as it should. Finally, on the right, we have a button. So let's just add a button. Actually, before we move on to the button, I'm just taking a very quick look at this error. So even if you ignore the error, you think that the stuff on the left is working. So this error is a TypeScript error. I mean, the app is in function. It's just TypeScript is like a way of enforcing types, but it doesn't really affect the build of the build version. So just to be able to see the app now. So I will continue this thing. And let's add the button. So I will add the button. And then if you add the title element, you should be able to see this button here. And if you see that, you know, there's some styling there, it is styled. So that's why when you hover over it, the tag increases. Now, when you click on this button, so you want to, you either want to sign in or sign out. So let's take a look. So this is you can label here. So it's cross, right? So now here's the concept of cross. So this header, you can think of it as a function, right? And if you take a look here, header, we are passing in two, you can think of these as like parameters, constant parameters. So already passing two parameters, in React, both these are clubbed up together. This header function, both these parameters are clubbed up together, and they are placed inside this props object. So if you ever want to access these parameters that you passed to header is kind of like deconstructed or access it with like, because it's an object, right? So you do something like props.user to access it. So if props.user is not equal to 1, and notice the 1 equal to the number, this will even, like, this is a much more lenient case. It captures like, it's, yes, like if you add 2, then undefined will also satisfy this case. Undefined is not equal to null, but we want to say that if an object exists, then sign out, so this is already there, else sign out. So this is some JavaScript stuff. Now, you might notice that I'm adding these curly braces here, and that is a way of adding some JavaScript stuff within of some JavaScript within of like an HTML looking code. So it's like I think called GDSC. Yeah. So let us take this error here. So yeah, the HTML buttons continue to happen. Now these buttons are currently empty, but we're going to kill those. So yeah. This is error. It's not fine. Oh yes. Okay, so let's just add null here, and that's what it is. So what you, so again, to recap what we probably said, if they created this user state variable, so they have user and set user. Set user is way of changing this user. You can ignore this one. Just all you need to know is say react.useState, and the initial value of user should go in the parentheses, and so that's now. Boom. So that's it for our use. We complete step 1. So let us you could connect this code in this, I'll just say completed step 1 or something like that. But since yes, I mean it's fully fine because delete this. So I would delete it, but if you like you could connect this code. Yeah, and that's where I want to step 2. So you want to change that. So I use this great tool, this great extension in VS Code called graph. So that gives us this graph with an interface to create branches. But it should be the fundamentals of that creating branches through the command line should be strong enough. And should be strong, and then we could use some hypertools like these. So hopefully you graduate workshop help you to build those command line skills. Cool. So now, if you head over to step 2 start the flow. Alright, and let's take a look at what tools we have here. So in step 2, we want to build this toggle switch. So let's build this toggle switch in React. So first thing is let's create. So again, you want to store the state of where is the position of this toggle switch, right? It could be either a driver or it could be a driver. You don't know. So you need to save. I mean, not you don't know, but you need to save them a variable. So let's just have points, and let's select it down, and set selected stack. This is like a common convention. Just name the setter. Just prevent it with set, and then have the same variable name. Again, we have .useState, and this we can have it like a number or something, and it starts off with 0. So the selected tab starts off with 0. Now let's add our tab. So we can create a component called custom tabs. So we have in our project structure, if you notice, we have this app.csx, which is where it's a main screen that you see. But we also have a folder called components that has a couple of helper components. So in that we have pre-created a helper component called custom tabs. And again, a component in React is very similar to like a function. So let's think of it again, components as a function. So we have this function called custom tabs that's we're going to style. So let us inside add procedure, let us call custom tabs, and it's expecting a prop, so that's why it's an error. So it needs selected tab and on tab selected. So let's pass those. So if you hit control space, you should be able to see what parameters are required. Oops. Or complete not here. And on tab selected is set. Oops. Set selected tab. So it's just passing down these props. Alright. And so this is complete with something. Yeah, and okay, this means one more parameter called tabs. So our first tab will be driver, and the second tab will be rider. So we pass to this custom tabs function 3 parameters. So let us unwrap those parameters and let's use them. So we head over to our custom tabs.tsx, and yeah, so this is a JavaScript concept. So if you have played around with JavaScript, you will kind of notice this is like an object deconstruction. So previously we used props dot something. If you have the deconstructing tools. So if props, so if you hover over props, okay, it says custom tab props, but props has basically tab selected, tab and font tab selected. So let's go straight to code and I'll explain to you what this does. So if you look at our website, right, nothing is there. So let us add inside the div, let's add. So we have this tabs array of strings. So we'll just do tabs right now, and we are getting these are profile distributions. So that's what's happening. I would highly recommend you to download that extension. It's free for students. So anyway, tabs.map, again, a JavaScript concept. So let us say tab, and for each tab we want a button. And inside the button, let us show the content. So you should see these 2 buttons here. But this button needs to know what is selected. So let us say data selected is equal to. So if I just say true, both tabs are selected styles. So again, if you are unfamiliar with what this is, like data dash something, so a data attribute. So I mean, it's not required to pass to a button, but we have corresponding CSS styles. That style when the data selected is true and data selected is false. So that's the only reason why we are passing data selected. So if you make this dynamic and not this hard-coded, you should say the selected tab when it is equal to. So let us also add an index. Again, this is the JavaScript concept .map. So I'm going to say when the select tab is equal to the index, make the selected. So if you take a look at the DOM, you notice that this first button has data selected true, second button has data selected false. So I'll probably move this on the right. Cool. So alright, that's that. When you click on this, something will happen. So let's add the on click. So in JavaScript, you will have the on click in small letters, like you have in big. And there you cannot place an on click within an HTML thing. So anyway, here you can do that. So on click. So when you click on something, just call on tab selected. So on tab selected, and pass the index. So now, if you click on the tab, it should change. And if you take a look at the tree here, data selection properties also change. Now, why is this not centered? Let me see if I'm selecting the step here. Well, we have followed everything that's Yeah, and I mentioned I will explain this after writing the code. So the stabs here, I could also set perhaps the props.tabs. It's all the same, but because you can setting all these whatever was there in props, just deconstructing them and creating three separate variables so that we don't have to say props.polygon. Cool. So let's see if we completed all the tools in this step. Yeah, I believe something's left out here. Yeah, let's just wrap this with a name tag, and this should center our toggle switch here. Cool. So this is the step 2 completed. So we could click on we could commit to this this commit completed step 2, and I will submit this. I won't push it because as you all will see this. It is not the intention. Step 2 starting code with just switch bit. So let's head over to step 2. So again, if you're following this repo after the workshop, yeah, this is how you do switch branches. Alright, let's take a look what we're doing in step 2. In step 2, we want to add, when you toggle switch, we want to show some text here. So it's going to be a pretty short step, and it's going to be similar to what you've done before. So, yeah. So, alright. We are in step 3. Let's take a look at all our to-dos. Oh, I think it's quite long. Yeah, I would say it's still relatively less. We just divided each to-do in multiple subparts. So, we have a helper component called page section. So we can use that. So I'm just going to follow this. So in our driver section, which is obviously here, I think this to inside the div. Actually not inside the div. Instead of the div, let us return a helper component page section. And inside this, there's pass and props. So class name, again, this is, I'm going to use it just as it says, because there's some sort of styling associated with it. Section header is what you see this bolded text. So, and when you are here, you should say here are your slides. And the section subheader does just say, okay, so figure Cooper is given us a suggestion here based on what we see here. So, we should be in this, okay. Yeah, alright. We'll see this new topic entered here. There'll be style page selection. So, actually, okay, step 1. Let's head up to step 2. So, in step 2, we can show a form. So, let us just use another helper function that we have predefined. A helper component called rider fill form section. Again, not to get confused, all those helper components are in this components folder, so you will find them there. Alright, so that is step 2. And in step 3, the rider fill form section. So if you notice that what it is, what's the page section? It's just that titles, subtitles, and some content. Okay, so if you notice in the driver section there is title, subtitle, and content. In the rider there's title, entry, subtitle, and content. So that's why in the driver fill form section we also use this component called page section. Oops. Let's have a self-closing tag. And let's add the props. So class name, let's add the driver section. And for section header, we'll say request to write. So this is what we planned on. So that's why we are adding this. Because of course you get your liking. We don't get any subheader here, so section subheader, I just leave empty. And for children, we have this hyperconflict of a request write form. Request write form. So this just returns as a form, but it's empty, so it doesn't matter. Once we start gate section, we will see all this. So let's go to gate section. Cool. Now here comes the fun part. So I want to see at least some patterns of what we're doing. Like we are calling a function within a function. So in case you haven't got digit repeat, so I shared in our group, so someone from our coaching could share that before. And by the way, so let me just pause and ask, are there any questions that anyone?
He could hear y'all, by the way. Or you could relay your question to me, and I could, because the mic's over here, so he'll probably hear me better. But if any of y'all have any questions, y'all could interrupt at any time.
Yes, please. Yeah, just please interrupt me.
They seem good, Rohan.
Did you? Perfect. Yeah. And again, don't give a get like everything right now. So let's just get you over. Because a beginner level workshop, that's why we are. I just try to get the flow of talking to them. And I'm trying to explain the concepts used, and then how to do it doesn't matter. Like, as long as you know what are prompts, you can extend this to your app. So don't worry about that. Cool. So our gate section is getting some prompts, which you always pass, right? You notice in gate section you pass the section header and all that, and driver section you pass the section header. And we do show the section header. So in gate section we have received the prompts and we are deconstructing it, so you don't have to say prompts dot all the time. And let us do some styling here. So let us add the class name that's given. We can take it a little slower too. So just to make sure that you all understand. Good. So class name, let us use the prompts that we are getting from the top, and let us pass it down. So let's say class name. And now, if you check in our tree, you will see this div here with this class driver section. And when you change it, you see another div. Oops. So I just wrote this component, but I didn't return it. We're still returning a div. So let us return this component, and you will see what's the effect of parts. You can see now is that that should be right. So here you have a div of driver section, and then you have a div of driver section. So that's how that's how gate sections work. So in that gate section, let us so we have section header, section subheader. So let us decide so section header, and let's add a few tag for section subheader. And now we should be able to see those. So you can see section header and section subheader. That's all that's happening. Is that we have this one gate section that's used by both driver and driver sections. So that's why it's kind of like a similar UI. To get this styling to look exactly like our finished app, let us add our class names. Because again, like I mentioned, there's CSS styles that we are doing. So for this, I will say section header, and here I will say section subheader. And now, hopefully we can correctly. And we also need to add another class name of page section, because that's how the CSS style would work. So yeah, alright, that would work. Yeah, so like I'm not just like yeah, if you just follow these studios when you are working on this by yourself, you should be fine. Alright, and finally let us pass it to me. Alright, so that's it for this step, and let us I'll just say completed step 2.
Hey, excuse me, Rohan.
Yes.
Is there a chance that you could make the font size bigger,
Font
like
size bigger?
the editor area
Yeah.
bigger? Okay, thank you.
For sure. Yeah. Yeah, absolutely. So this is step 3. And let's head on to step 4. And step 4, start with code. Alright, and let's take a look at what we should have here. So now we start to write. So let's see how it is correctly. Step 4. Oops. Step 4 is. Alright, step 4 is just some 5D stuff, but it's not visual change. And that's why there's no change in our screenshot. So now let's do some 5D stuff. So we are going to download the latest driver information. So what we're going to do is in a React use effect. So let's take a use effect as a constructor. Make sure we pass a function and then an empty dependency list. Again, this is probably a little out of scope for a beginner level workshop. Just know a use effect with a function and an empty dependency list is probably it's not probably, it's how we do a constructor. So here we create a Firebase query. So I'll just say u is equal to query. This is a Firebase function, and I will say we have a Firebase database here, where this is a collection of drivers and drivers that have a few documents. So we want to get the drivers collection. So it is a collection. Firebase DB, which is let's just pass some database information. So let's pass that. We want the drivers collection, drivers collection, and we want to get all the documents here. And we want to order these. So what am I missing? So I think okay. So yeah, here the order by the latest request will show up at the top. This is like a select statement in Firebase. And now let's add something called an on snapshot. Now, I mean, there's really no multiple ways that we do this. Like it's almost like just one way. So we're just going to go through relatively quickly because you kind of will have to just read the docs and do it anyway. There's nothing much you have to understand. It's just the way you do it. And I'll explain the underlying concepts across. And so let us so this query snapshot is the snapshot that we get. So let us update. So let's create a state variable. As parameters. So yeah, I'm just going to take the complete station. Since it's a very good stuff, we just want to show the goal of this workshop is not to code an entire app, just to explain the concept. So I think I give more time on the explanation, and let's just try to use some of the help that you have to write code quickly. Cool. So we take the snapshot, and we take the document inside it. So the docs are all these things here, and the docs, and let's map these. So we are going through each document, and for each document, we want to create we want to create a new item. So it is dot dot date, right? we estimate to create a new driver and will set this type to of that driver. It's again some TypeScript stuff, but this will help us out in seeing what all fields are left. Now, if you want to access stuff in a document, it's doc.data. So if you notice that a document has a couple of fields here, so this is accessing a field. Doc.data has name, and we'll just quickly add the main stuff also. So quick application and drop off application. And finally for our request based time, so this is a timestamp, so we need to do seconds times 1,000. So to recap, we are making a field. On snapshot is kind of like a way of boosting for changes. So whenever a change happens, this function will take it here. Right? We pass second element to the on snapshot. This function is called, and that creates a new driver, and new drivers for map. Oh, I think I'm doing something wrong here. Like you just want to return this much. Let's see.
I think it was new riders with like a S, Rohan. I think it was just a typo.
New riders. Yeah, new riders. Well, I think there's something wrong there. We want to take a document, we want to return. I think this much portion, this one. I'll cut this out and remove this stuff also. How we can return this? Yes, this return and this. Yeah, this should be good. And now we will set this as riders is equal to dot map, so JavaScript can be taking a document and we are returning these rider objects. And now here that we have the riders, let's just call set riders. There's some TypeScript stuff, so we just create a rider this, and this we will rider. Okay, here's a signal that there is some TypeScript stuff. And if you done everything correctly, this looks good. Hopefully not crossing. You should see our riders information. So we have 4 riders here, and that's just corresponding to all these riders here. So you have a JSON object, a JSON array of objects. So you have name, email. So name, I think, we'll say doc.id. So yes, so doc.id. Yes, you have new documentation, application, and request based time. Cool. So this step, all we have done is download the file information. Like we have covered in at least a little bit more detail most of the underlying concepts. So now we just go slightly quickly, and we might go slightly over time also. This is by time on. Yeah, so we can just see our finished artwork. So we'll head over to step 5 and start. And again, if there are any questions, please let me know. In step 5, we want to see this rider task. So what we will do is we have this riders already here. We just need to show tasks. So again, the only thing is if you have something and you take a format of it, we can do a riders as map. And for each rider, we want to return a rider tag. And this rider tag is a helper. So let's say rider, and let's remove this. So we completed these steps here. And if we notice, just have you done set 2? Okay, so it's updating. Oops. Alright, this is a big thing. So we will style the cards that you see. Currently the cards are, showing nothing. So I'm going to do this, so you can take a look at how we are building something here. So I'm just going to take the return, okay, and this div has spider information. So you can just say rider dot name. Oops. And you can see all the names here. You can say rider.name, and right next to it you can say rider.name, and you should give C name also. So yeah, so that's what we do. We're just unwrapping the rider information pretty much here. This step is all about like styling the card. But finally, Adam, how much time do you have?
You're good to go over, Rohan, for a little bit. I'd say probably maybe around 10-15 more minutes.
Good.
Clint said it's cool if you want to keep going at your pace. That's okay.
Thanks, yeah. Okay, I still go through that. I've tried as quick as possible, but I still want to explain the concept as much as possible. So I'll try to find a good balance and before that day. Cool, thanks. So this card here, and I'm going to style this, and the next time if you style this card, you'll probably just skip that since it's running for time. So the slider here, if you notice, in the graph you have 2 rows. Once this first row is the dividing line in the second row. So the first row is divided into a left and a right. So we are going to have 2 divs for the different class names. I'm just going to say row 1 and we get to row 2. And within row 1 we have we have 2 things. So that's we have 2 things, left and then right. Within left we have 2 texts. So let's add that here. And here we have a text that has rider.name. So this is as if the writing stuff fairly quickly, but the underlying concept is kind of we all know that is with this is just HTML stuff. So don't worry about that. Yeah. And the questions please ask. So rider name, and just probably add this in a JavaScript string. So it will be rider name, and then we can add a space, and here we can say rider.name. If you're curious on what this is and you aren't familiar with JavaScript, this is just string interpolation. So you're taking a variable, putting it in a string. Good. So now if you take a look at our app, you see this, and if you do that, we have another key tag, but what's inside it is the time. So let's just do new date, using the rider dot request base time. I don't see the time string or something. Let's call this function. Alright, and you should see the date and time. Yeah, it's fine. It's a way to to the time string. Yeah, so we show that. And on the right, we show the spending. So on the right here, I will just add. So if we try to take help from here, so the CSS defines as a key tag. So key tag, it has rider.space. And let's add some styles here. So class name rider column. Alright, and we get the CSS style that has style. So to the space, if you add the style of space, oops, no. you should hopefully get that. Yeah, I think the other side is fixed by size. Good. On row 2, we have a strong key. I'll just do it very quickly and probably copy this in here. And row 2, we have rider.from. I'll just say rider.put again. And here I'll just say rider.drop-off again. And I have to put this in the left. Then class left. And I will move this down. And so yeah, you can see this here. Now the right just have a select. So I'll add another here. Then drag them up right. And select. And inside select you can have multiple options. So I'm just going to take take some example options here. Let's see. Right here. So
Select is misspelled, Rohan.
Thanks. Alright, so we get a select and we get some options here. Yeah. The concept is same, just we can correct options to what we have in our finished draft, which is tending on to pick-up and drop-off. So, cool. Yeah, we come with this. I'll just go back to it. And let's go with this. And any questions, please interrupt. If not, let's move to step 6. How can this is exciting to see we are downloading stuff from Firebase and displaying it. Yeah. Step 6. If you take a look at our finished form, here we want to create a form. So this is a form requested ISO. 4 input keys and 1 request write button. This is going to be, let's head over to our to-dos. It looks pretty short. So, if you notice in our form, there are 3 keys: name, pickup location, drop off. Email is kind of disabled, so we'll just ignore that. So, if you remember how do we create a state, is using the set state. So set state, and yeah, here we will add this one as an empty string. So not set state, we use state. We create such variables for name, pickup, and drop off. And drop off. So now we have 2 state variables. Then let us call label input. So I'll just do it for 1. Just 1 input will be fine to demonstrate. So let's add some required. So everything without the question mark is required. So I'll just add that name. Let's add that name. Label is with name. Form ID. Let's give the form ID that's created first. So not going to complexity because there's a form ID here. And what else is required? Yeah, and value. Let us give it the value of. Let's put it up with these state variables. I'm saying. And hopefully. Let's find this stuff here also. So I will just use our suggestion. So label input is just having a label at the top and then an input. This is again HTML thing. So there's nothing too different here. And we get this name field here. And default section. And then we just create an input of type submit. And that will be our submit button. Oops. And here input, and I will say equals to 5. And you should hopefully see it's a mess something up. So if I mess something up, so yes, so and we add a button that does this. So this is just form creation, nothing to do with too much React stuff here. It was just set variables and then you have to do UI. Just cover this input here. And the several steps are we are near the end, so in step we get all of this done. In step 7, we are going to do some authentication. This is a straightforward 5-base code, so you could probably take this code that you have here into your school projects and just use the same authentication code. Because the way how this authentication works is just that there's just one thing. So let's complete the signing method. So I will say launch provider is equal to Google auth provider. This is how to use Google signing in your app. And then let's call this function signing with pop-up. What's the image here? Let's do that here. So now, if you click on this button, you should hopefully see a pop-up come, and it just, and how people say like just a few lines of code you could get that pop-up. Let's see. So if there's any error, you can still console.error. And you can see because there's some error that's happening, I believe. No. But yeah, there's something. But more or less, this is how we sign in, and to sign out, it's you can just call this package thing called sign out, and yeah, that should so when you click on this button, it will toggle the sign in and sign out state, and so that's why we need this here. And finally, let's listen to any changes in our authentication or state change. And whenever the state changes, we update our state variable. And the reason it's growing is because it's automatically signing it into our GDSC account. Because I've already signed it. So if you click on it, it signs in and shows the profile picture and now. So alright, so that was correct code. So good. Alright, so I'll just complete it. And alright. And let's have step 8 and step 8. And here, so step 9 is the last one. So here I'm bringing it at the end. So it's hanging in the code. Let's do this. So we covered how to do 5-base spot. We covered how to do 5-base real-time read. So we know how to add and edit information, right? The current operations, right? CRTD, create, read, you update and delete. So that's what we're going to do. So when you if you take a look at this, when you update this thing here, now it will not allow us, since your services that only we can update our own. So if the GDSC creates the right, only they can edit their own. So, but yeah, when you click on this, it should update our files to DB. So let's see how to do that. refresh this. So let's just remove all the checks and we'll just when you click on request run, we want to add a write to our table here. So let's do that. So we create a JSON object, and I'm just going to take the autofill parameter again. It is based on the comments here. So I'll create a new object. To add this object to a file store DB, we can just call the Firebase function called set.doc. We're going to create a document in our database, and we take our database object, we tell it into which collection we want to pass it to, and so yeah, eventually we pass in new object. And also if you want to give an ID, we pass it, let's just create an ID of driver props.user props.user.name. Yeah, so now we click on request flag. So I will put this in side-by-side view, and you can hopefully see a new column coming in my database. So I'll just say GDSC, therefore here, probably there, and hopefully when you click on request flag, you see a new field, a new thing here. So again, it's just standard code here. Cool. There's also how to update and delete, but it's very similar to what we did. So we'll just cover this, and we'll end in just a few minutes. That's step 9. I'll just show you what it is, and we'll probably jump to the more interesting part. So step 9 is just boring code. I'll just say that. It's all about like having the same repetitive thing. Like we have this form. So, but if the write is requested to issue a write card, we have already created a write card on the driver side. These are to display the entry requested one. So, yeah, the code is very similar, and it's already included in our solution code. So, please check that out. Now, for the interesting part, can you all visit this website? And close this. This website. Again, if you need link, I can't share it this way as a one screen, but if someone can head over to a React repo and click on this link, so React repo is hopefully someone has shared it. Yeah, and once you are here, I don't know if you could really do it. Anything is needed?
Is he on?
Hello?
Hello, Rohan.
Yeah. Can you go to this website, please?
Yes. Well, this computer is streaming. I can visit it on my.
Yeah, not you.
Oh, okay.
No,
Oh.
the audience. Yeah, all of you in the audience, you have your laptops or your phones. I'll give you just like 30 seconds or so. If you can head over to this website, click on the sign in button, sign in with your Google account, head over to the writer section, and create a write.
Do you all have the access to GitHub?
Yeah. Okay, I'll share this in the Zoom chat if you can just share it with the
Okay.
Alright, so the fun thing about computer is you can see your name come up and you can see everything real time. This is how Firebase works. I'll show you your your attention. And yeah, interesting. Anyway, if you have any privacy issues, please don't do it. But if you're fine with it, yeah, we're all trying to know the use this for illegitimate reasons and for illegal reasons. Yeah, so yeah, so this is all available in real time, and you can also head over to the rider section. So you can change your own states. So for GDSC, I can do habit change the picture, but I can see the states change. So I can change the state on blue. You can change your efficient presence others. There's security for them. You can't do others. So change yours and enjoy speed and abilities in real time.
Thank you, Rohan.
That's what Five is all about. Alright, yeah, that's it. Won't take any more time. Yeah, sorry for that.
No, Rohan, that was great. I actually learned a lot.
I appreciate that. Yeah, so.
If any one of you couldn't follow up along, there will be a recording of this workshop on YouTube. You can go there and rewatch and learn something about React.
And it's also on the GitHub repo as well. And I also sent the link on the Discord if y'all haven't joined just yet. Alright, so before we get started on like our very last workshop with Quinn, I was going to see if y'all are probably interested in some food, if y'all are hungry. So we have two things. We have chicken and sausage jambalaya, and we also have cold pasta, like the tri-colored pastas. So hopefully it'll be good enough for everyone. Like someone could find their preference. Honestly, I was gonna say y'all could come up, but. Good thing, we should have only got one. We should have got two, bro.
The security, I don't know what the acronym is, but security society something. I don't know what it is.
I'm good with y'all just treating yourselves and plating y'all's own dish. It's not that deep. I know some people
Grab one with that bowl.
and how about we
Oh.
how many computer scientists do you think this?
Put them in a bowl.
There we go. Yes.
Where's it from?
Really? Pretty for the quantity. You know, it's actually really good for catering.
I didn't even know they could. I know they made like steaks and food. That's it. Thank you.
What is it? There's a lot of stuff.
You just put it on the table behind it.
Yeah. As long as they have the resources to talk, they're really interesting. They really are.
Is it on pause now?
Yeah, it's on lunch. We're on lunch break right now, guys. We'll be back
No,
in about
I'm
10,
the pause
5,
doesn't-
10 minutes. All right. Stream's live, Clinton.
All right.
Okay. And then if you want, use that way. Oops. Yeah.
Okay.
Perfect.
Sounds good. Okay, so what I'll be going over today, I'm going to give like some high-level information about what Google Earth Engine actually does, talk a little bit about the satellites here, and then we're also going to look at some code for this. And actually, I just realized this might be a problem because I'm running this in the browser on mine.
That's fine.
Okay.
Everything's gonna be,
But I can show the repository
Yeah.
I made here. That's
Okay.
fine. And we'll see the end result's kind of funny because I can't do math. So my original idea with doing this was to take a snapshot of PFT, and we'll see in a little bit why that was a terrible idea, and I cannot calculate distances at all. So to give you some background on me, I'm actually a third-year PhD student in the computer science department here. So I started here at LSU in January 2020, and I've just been here doing whatever I do, you know. I was working as a research assistant for the first bit that I was here, and then after doing that for a little while, I actually switched over to teaching a class every semester. So I teach a C++ class. This semester I'm teaching 1253. It is pretty fun. Like, it's actually very enjoyable. I get paid the same as being a research assistant, and it's more fun by far. But I don't publish very much or at all. That's the only downside. I kind of have a mixed background, so I started with my research doing a lot of machine learning, computer vision. I've done a little bit of data science, data processing especially. I'm not really very good at like analyst type stuff, but I was doing a lot of like video and photo detection type stuff with computer vision processing. And I moved into cybersecurity around that stuff too. So like what I work in now is cybersecurity, machine learning, and systems. So that's kind of where I'm at right now. So to go through an agenda of what I'll be talking about. So Google Earth Engine is an important part to this, but it's actually the least technical part of it, because Google Earth Engine is really just a barrier, a conduit between all of the technology and the processing of satellites and your computer. It's really just a conduit between all this other stuff. So I have to really talk about satellites, talk about what they're capable of, because they're capable of a lot. And then I'll go into like what is Google Earth Engine, what is the point, and talk about how we use these things together. And I'll give you an interesting demo which will show the use of it. It won't look nearly as cool as it could have if I had thought about that, but it will work, and it'll give you an idea of like how much domain knowledge goes into this, and you'll see what I'm talking about as I continue with that. So the first thing I talk about when talking about all of Earth Engine and image processing through satellites is the sources that are available. And there's a couple of different kinds of sources that you'll see when you talk about taking imagery of different locations and taking imagery in aerial views. So satellites operate obviously in space, if you've ever heard of a satellite. Satellites operate in an above the cloud position. So when you're talking about how a satellite is aimed at the Earth, it's actually a lot of complicated math to make these things line up with the Earth a certain way and calculate where they're straight or not, because they're incredibly far out into the very edge of our gravity, and they rotate around us. So when they're pointing down at us and trying to take images of us, it's actually a very complex process to get these things to take pictures of the Earth and it not be just garbage, right? These things are really expensive. There's not a lot of publicly available satellites that do high resolution imagery, but there are some that are very impressive. These are also amazing pieces of equipment because they don't just take pictures, they take all kinds of data from the Earth.
So it's not just taking some RGB photo of the planet like you think of like a DSLR. It operates at a much higher level of technology than that, where it's taking the red, blue, and green of our planet, but it's also taking things that are in non-visible spectrums. And we'll look at that in a little bit. These satellites, when you think of how far out they are, and the way that they're rotating around us, or we're rotating with them and they're rotating with us, right? They can actually cover very huge amounts of land at a time at pretty decent resolution. So they're spinning around us, and they can take images of large, multi-mile areas of the Earth at once, and just process that and then send it back to us through data transfer from the satellite. So they are amazing at recording large areas over really small time frames of, say, days or weeks. I'm also going to talk a little bit about aerial. So these are actually planes. They equip cameras with very specific technology and gimbal type stuff to planes, and they actually capture imagery below the cloud surface. So we'll look at how satellites have to deal with cloud surface issues. Aerial imagery is often very high resolution and looks very good. And they have a lot less spatial interference altogether, so it's not just the clouds themselves, but it's also the fact that our atmosphere has all kinds of gases and layers in it, and it makes the imagery not nearly as crisp as it could be, right? The aerial imagery is often very high quality, but it can't record nearly as big of an area. It's very contained compared to a satellite that is so far away it can capture huge miles of land at one time. They're also more restricted in the technology they have. So it isn't necessarily true that they're restricted because they're planes and not satellites. The size isn't really the thing. It's the fact that this equipment's so sensitive, and it's incredibly expensive equipment. They don't really equip them to record all of the different non-visual bands that we think of on these satellites. So while you think of the satellites as being able to record a lot of really interesting data at really high frequencies, the resolution isn't nearly as good as this aerial stuff is, but aerial mostly only gives us visual images. And we'll take a look at why we want more than just visual images, because that's not the entire story with a lot of what we're using this for. And really the frequency of these things is not very good, because if I have to fly this plane once a year to capture the entire United States, that's a lot of man hours. I have to go over several days to do that, and it's going to be very expensive to process all of the imagery that comes off of a thing that's swaying and moving around the entire United States, right? So it's a very expensive process to take this aerial imagery that's super close to the ground and process all of it and turn it into a flat map or something. So we start talking about bands. So when we think of light, right, so we are three-coned in the eye, so we have red, green, and blue if you're not colorblind or missing a cone. And we often think of a lot of things in terms of red, green, and blue. There's also other spectrums to that are really close to our visual range that we can kind of see, and it kind of affects us, but we really operate in the main three ranges of red, green, and blue that have these certain nanometer frequencies, right? I'll show you a second about all these different bands. Near infrared is right at the edge of our red. It's kind of it's not really something we see, but it's very close into our range. I think just falls out by a very small amount. The non-visual bands that are really important are things like our aerosols and our deeper infrareds of the Earth. Deep infrared is incredibly important for plant life and soil. And then the aerosols are actually very important to things like our oceans. So aerosols are kind of like large particles in the air that we can't visually see. They're out of our vision spectrum because it falls out too far from the blue range. But they're actually all around us. And if you can equip a camera with aerosol vision in that light range, you can see particles all over the place, especially with water. It's everywhere. These aerosols, when you think of things like ozone and you think of all of the particles that make up our atmosphere, we can actually see these things when we have the equipment to do it. When you start throwing in this deep infrared data and this aerosol data, you can, forgot to do this. When you start throwing in this aerosol data and this deep infrared data, you can learn everything about plants, water, and the weather of the entire planet. So when you can track aerosols, You can track how the water moves, what the water's doing, what the weather is doing. We gather more information about what our clouds are actually doing inside of them, more than just visual. If I have just a visual look of the top of the clouds, they're clouds. But if I can see things about aerosol and the reds coming out underneath them, I can actually understand things about our weather patterns. What you can see here in this animation is actually a visual of the deep infrared of Africa as the year passes. So you can see the vegetation over Africa for a whole year going back and forth. This is like our natural cycles. And you take the Earth and you look at its natural cycles, you can see changes of it over time. So let's talk about the actual, like when I'm saying wavelengths and bands, what I mean by that. So if you take the nanometer, basically the frequency of the waves of light, right? So our visual spectrum goes around that, I believe, about 440 to 780-ish or so. That's our red, green, and blue split up. So we have a red, green, and a blue. And our eyes see it a certain way, and cameras see it at certain widths as well. So it kind of varies a little bit as to what red, green, and blue actually are altogether, but they're generally in the same area. Infrared is really important for the plants because the reflectance of infrared off of plants tells us how healthy they are. You can actually look in the deep reds in these really wide, swathy waves. You can see if a plant is healthy or not because the infrared will flash you really hard, and if it's flashing you low, then the plant is unhealthy. So you can actually track the health of crops over time based on the deep infrareds of them. Going into UVA, UVB, and UVC, and those ultraviolets, this is where you start to get in the aerosols, and you can tell things about the atmosphere and the water through those. The deep blues of the ocean will tell you different things about the health of the water and such. And you can actually look down into them if you have the proper equipment and start to see how healthy the water is based on these non-visual things that are coming out of the water. Okay. Are there any questions about that up to this point? Are you enjoying?
I have one quick question.
Yes.
It's kind of like about satellites. Assuming they're like any other technology that they're program coded, right? Does that bring in like some security issues? Because I never really heard of like satellites getting hacked, but I've seen like cybersecurity club, they'll do like a hack-a-sat challenge. Like, is that even possible?
Yeah, but it's sort of closed off in a way. So when you think of like hacking things, when you think of like the up and down band, right? Of like I can send something to you, you send it back to me. Then up and down can cause a lot of exploitation. These things are mostly equipped to be one-way machines. So they're equipped to take things and send them back. And eventually they'll die. Like we don't send off like updates or anything to them. They'll eventually like die, and we'll let them float around our atmosphere, or they'll get hit by something and die, something like that. We kind of send them up there equipped as they are, and they send us data back down through radio transmission, but we don't really interact with them outside of them being communicators. Okay. But yeah, if you could deal with them that way, like these particular ones, it would be pretty bad, and that there would be a lot of security issues with that, but they process and secure it pretty well. So the first actual satellite I'll talk about here is the Landsat 8 satellite, which is like pretty phenomenal. So it was launched in 2013. Landsat 8 is a series of satellites. It comes from a series of satellites that are famous for going back to the 80s. So they started equipping these things with like several different bands of information and setting them up decades ago. We actually have information over the past 40, 50 years from all these satellites recording data around the Earth in different spectrums and different light ranges for, I mean, as long as we've really thought about the environment as much as we have, honestly. This is a really amazing amount of data that we have. It's also a huge amount of data that's hard to store everywhere all the time. It takes petabytes of storage to keep all of this data together. The Landsat 8 one specifically, and there is a Landsat 9 now, but it's more for like capturing the Earth as a whole over really big areas so we can track the weather. Landsat 8 is actually used for visual and for those multi-spectrum type things outside of our visual range. So every 16 days, it captures a new image of the entire Earth. So it runs around and gets a full capture every 16 through 11 different bands and a lot of condition detection tools. These aren't nearly as cool as the other one I'll talk about, but the full 11 bands give you that range of your RGB and 3 different infrared bands and multiple aerosol bands. So you get a lot of different data off of this one. When you start taking that infrared and splitting it up into different ones, you can tell all kinds of different properties based on which range of the infrared you're looking at. It's very cool. This one in particular has a 30-meter pixel resolution, so each of the pixels is a 30 by 30 meter box, basically. And there's calculations to this and how you deal with it, but that's about what that means, basically. Sentinel-2, which was launched in 2015, is also a really cool and impressive satellite system. So this one's actually 2 different ones that they launched at the same time. One of them is at essentially like a North Pole position and one's at a South Pole position, and they rotate and capture the entire Earth as a pair. This means you can get the entire Earth in 5 days. So every 5 days, the Sentinel-2 system actually sends in an entire recapture of the Earth. So you can get granular down to every single week of the year of recording multispectral data across the entire Earth. That means week by week you can track everything about our weather and plants and just record all that information and do what you want with it. It also captures cloud coverage, which is really cool. So it has an algorithm it uses for detecting if something is a cloud as it rolls along things. So if there's too much cloud coverage over an image, it can actually throw it out automatically because it can tell how many pixels in the image are clouds. So you can put parameters on this one to say, I only want images that are like 20 or 15% cloud max, and it will actually give you the ability to throw out things that are too cloudy. You don't even have to manually process it because it's already equipped with an algorithm to do it for you. Which I think that's really cool. That is like super useful when you're trying to like get real photos of things. Sentinel-2 is also much better for the visual resolution. It has a 10-meter pixel resolution, so basically 10 meters by 10 meters. It is pretty commonly used when people want to take like a large area and track some kind of change in things over it in a pretty short amount of time. Like when you talk about a lot of these really high resolution ones, they can only do it so often and it doesn't give you a high enough granularity of time to say, I see this change week by week or month by month. And Sentinel-2 does it pretty well at 10 meters, which is a pretty good pixel resolution for something that captures every 5 days. So NAPE is actually the aerial one I'll talk about. So the other 2 are satellites and they capture very well, but they're actually pretty large pixels, right? NAPE is the smallest one out of the publicly available data that there is, and I'll talk about how these are all publicly available in a second. It was started in 2003. In 2009, they started recording every 3 years, and again, it's very expensive to process, record and process all of this data every single time. So it's a very expensive and kind of long-winded process to align, put things together, and record everything, and then process it into a public database. It also only has 4 bands of coverage, which is the 4 I talked about with our RGB and near infrared, so it has a little bit out of our red viewable range in there. That gives you a little bit more information, but it's almost entirely there for visual purposes. So if you want something that's high resolution and visual, but with every 3 years of coverage, you can get NAPE at 0.6 meters per pixel. So it's good quality if you just need a picture every few years of something. And this one is an aerial, to be clear about that. So it's kind of slow in how fast it collects the entire United States. It does take months to do so. Okay. So what does any of that have to do with like Google? So in 2010, Google launched the Google Earth Engine API. So what they decided to do, because all of this data I just talked about, Sentinel, Landsat, and NAPE, are actually supported by federal agencies. Some of them are through the USGS. Some of them are through another one whose name I can't remember right now. So this is all publicly available data that is free to use, but it's kind of hard to use because you have to go to different sources. You have to find what you're looking for, basically in a magazine catalog of looking through images and trying to find what you need. And they don't really make it nearly as easy to process on all of the different bands and data as they could be. The data is all there, but they don't have sophisticated software engineering systems to deal with this. That's where Google came in, because Google does everything. And in 2010, developed the system and started collecting all of the publicly available imagery data they could between all the satellite and aerial sources from public agencies. So it is very heavy in server-side operation use because you want it to be. It is very possible that when you're in the middle of these operations and trying to do something with it, you'll accidentally pull about 3 or 4 petabytes of data and then try to save it to your computer, which would absolutely crash your computer if you did it. And it'll protect you from doing that, and it'll stop you because it'll say it's 3 petabytes of data and you don't want to do that. Pretty much all of the really complicated processing stuff takes part on their servers, and then when you get down to something that's nice and is contained, like a small collection of images or a single image, it spits it back to you from their server side to your client side. It is distinct from Google Earth, so it seems like, it would tie in a lot. It does a little bit, but Google actually uses private satellites for their maps and Earth imagery because the publicly available imagery isn't high resolution enough for capturing the cat walking down the street on Google Maps. So it's a little bit they're a little bit removed from using it in all of their stuff because it's just not that good. They actually use this thing called Maxar. They have I believe it's 0.3 meter satellites, so they're incredibly fine-grained and really great satellites. Also cost millions of dollars to get that imagery, and you won't get it unless you're rich. So Google has access to that, and a lot of companies don't. So Google Earth, because of all this private data they host through there, they have a lot of really good visual data. Earth Engine, though, all this publicly available data and these satellites with tons of different bands on them gives you the visual part with a little bit less resolution. It also gives you spatial data. And the spatial data is very important to make things like analyzing plants and the ocean possible. You have to have that. You cannot look at a crop of plants and actually know if it's better than another crop of plants unless one of them is just dead. It's very hard to tell the difference from space. There's a wide variety of resources to this, so I'm actually going to reference in a minute the data sets link they have. Domain knowledge is necessary to do anything with satellite data, especially the way that Earth Engine has it set up. And you'll see that when I switch over to actually doing a call through it. If you don't know exactly what you're doing, it doesn't work because everything is based on strings. You have to send string data and JSON data and format it the correct way. And if you're correct about the satellite that you're using and the information about that satellite, you'll get the correct response back. If you're wrong, it gives you nothing back. So you have to have domain knowledge of how to use it to get anything to come out of it. I will be using the Python API to demonstrate this. This is a very simple call that I'm doing with this, but it is painstaking to learn in the first place how you're supposed to use the API. But they have a lot of guides and a lot of good stuff. This data, the data and information about how to do this professionally is super siloed between a very small group of people. Just learning how to be a novice at this is honestly kind of hard, and understanding the domain of I want to measure stuff about plants is kind of hard. But I'll be referencing that data sets link in a minute when I go through the Python code. So the sources for Earth Engine are all publicly available data. There are some really nice ones on there that were public initiatives where private companies were taking their expensive satellites, companies like Planet. If you're familiar with Planet satellite data, it is amazing. You can see leaves in high quality. All of these sources are from public agencies and departments. Those agencies and departments are the ones who own these satellites. They own it, and it transmits data to them, and they process it through a very complicated and expensive processing processing system of I'm going to take all the data, store it correctly, and store it on our servers. And then once it's publicly hosted, Google will take all of that publicly hosted data from these different agencies and conglomerate it into their servers. So they are hoarding all of this data on their own servers, but it has to be publicly available data, otherwise it wouldn't legally work, because you can't just like scrape privately captured data and then start hosting it, right? And Earth Engine also has a policy about that you can't like start selling publicly hosted data through Earth Engine because it's supposed to be federally funded and free. There's actually people who have gotten in trouble for that because of the legality of selling stuff that's supposed to be federally free. Most of the data sets are actually updated in daily cycles. So as soon as the data becomes available to the government and then it becomes available to Earth Engine, it becomes available to you. It's actually a very fast turnover for this data coming down and then being brought to you through Earth Engine. So it's super fast. Any questions about any of this? Are you having fun? Yes.
So when the Sentinel and the Landsat is going to break it down, you're saying the pipeline goes to these agencies and they process these petabytes of data.
Mm-hmm.
And then you said that they will do the server-side rendering in terms of putting it to a computer. What kind of server-side things are they doing other than accumulating all the links from the different?
Right, and that's the main thing they're doing other than the API. So when the federal agencies get this data, Google basically just scrapes and pulls all of their data to their servers, and they're the ones that do the processing through the API of, we've pulled all of this into the Google servers, and now you can send API requests to filter it to a very fine grain of what you actually want. So if you're trying to find this through the agencies themselves, the federally funded agencies, they're okay, they're fine, but they don't provide you like a proper programming API to do this with, for the most part. Some of them are okay, but most of them are pretty manual. They're expecting some dude who's doing a survey to come in and find a couple of pictures he wants of some land. They're not expecting you to do massive data manipulation. So that's where Google really shines, is like massive data manipulation and repeatable processing. Is that a sufficient answer? Okay. Okay, so we'll talk about the uses for Earth Engine. It's kind of interesting because Earth Engine, even though it's super useful, honestly, for private companies, it's mostly seeing use in universities and labs that are doing natural sciences. So when you talk about agriculture, crops, soils, oceans, changes in the rainforest, ecology, preserving the animals, preserving natural wildlands, a lot of that's in there. Urban expansion. That's a really big topic there too. So the ones you'll think of when you think of like, oh, it has a bunch of data, it tells me stuff about the environment. I want to know how the climate change is, like climate change in certain areas is happening, how it's not happening in other areas, why are places different, weather observations of, wow, this place is getting hit by a lot of hurricanes, I wonder what that's about. Cropland of like, is this healthy crops over here? Are these dead crops? Why does it seem like all of the crops in this state are getting less and less reflective on infrared every year, while the quality of the soil is going down, and say the nitrogen content is going down in the soil? We probably need to do something about that and fix it. So a lot of this is research topics. It's very much research questions, but private companies also utilize it for profit, however they can. So when you have companies that operate in farmland and oceanography, those are the really big ones. You'll see places that are huge farming states. A lot of these places are finding ways to incorporate Earth Engine to make money. They're selling some kind of analytics about land or farmland or crops. They're selling information or strategies about how to deal with erosion in places, or the coastline, how you're going to deal with the coastline, make observations or actuarial ideas about, like, oh, you probably don't want to put a house there. It's literally going to be gone in 3 years if the coast keeps eroding the way it is, stuff like that. And then land, if you'll see this is kind of interesting because the thing that happened with Joe Burrow recently. Buying up land. Why are rich people all buying up land? Joe Burrow, Bill Gates, and everyone else is investing in farmland and crops now. Why is that happening? And it's probably a lot to do with, when you think of it in terms of scarcity, you can't make more land, right? And the more that land needs to be used for crops to make more food, you turn into a big profit margin when you buy up this okay land, and then it has to be used for crops. So now you're flipping a lot of money that way. That's actually a very new alternative commodity market, is the buying and selling of land and farmland in that capacity. It's a little cool bit about that. You'll see a lot of rich people are buying farmland now. Okay.
Does it come up and put the GitHub on that computer?
Yeah. Yeah, you can do that. Yeah.
Because it has like OBS set up on it and stuff.
Okay. Are there any questions? Yeah.
So this data that's coming from satellites, is it because sending them these pixels and have a JPEG, is it have an image format? What is
That's actually a really good question. So all of this is proper GIS data. So this data is originally recorded as geotiffs and has a lot of data recorded alongside it. So it's not JPEGs or PNGs originally. It's actually very dense data with like information per pixel about its GPS coordinates, what kind of coordinate system it's using, stuff like that. So it's a lot of data in there.
Yeah, I don't know where you're exactly.
Oh, yeah, I can pull it up. Yeah. So there's a lot of data. Oh, it's backwards. Oh, geez. Mac.
Yeah, I'm worried about that. I'm about Mac over there.
So, this has the one file in here for the notebook I'll be showing. So, just like for a reference, this is here. Yes, so the geotiffs. So all of this has a lot of data attached to this, right? So when you get these swaths of data, it records it kind of in swaths. You'll see like some of it's not very straight. It's like collections of data. So you have to have references of like, when was this recorded, information about the pixels themselves, of where are they, and GPS coordinates, all kinds of data like that. And the information that's recorded, along with the satellites especially, all these bands of data, is transferred with it. So originally these are not like rasters or anything like that. They are really heavy, dense data. You can transform them into rasters, but they are primarily for GIS purposes.
the satellite is not transferring any sort of self-referential thing like, oh, I got this squad and this is into this squad, get back to the job of the inside people.
It actually does transfer that. So it transfers its angle of attack to the Earth and transfers information about its trajectory along with it too, yes. So because you need that to make a proper rectification to the Earth, right? Because if I'm at a certain angle to the Earth, that changes what is up. And yes, it does need to transfer that information to ortho-rectify it to the Earth. Okay. Okay. Before I go to the next part, are satellites cool? The more impressive part about this is that the satellites exist, honestly. They started doing this in the 80s. Like, it's insane that they, like, you think of the 80s as being old, like they were still VCRs. They were making this technology and deploying it into space regularly decades ago. It's crazy to think about. Okay. So I'm going to run this through a Pi notebook because it's kind of just really nice that way. Oh wait, do they have a light theme on this? Is it? I don't think they actually do on here, do they? Well, oh wait, hold on. No. Well, I guess they don't, so we'll go with this for now. Okay. I know it's really dark.
Oh, yeah.
Oh, no.
I don't know if it's that's what the wall over there.
Oh. Okay, that's good. Yeah, thank you. Okay. So, and at the end of this, well, in the middle of this, you'll see I was dumb when I said I was going to do what I was going to do. So, Earth Engine requires a bit of a setup process, so you do have to go through the full thing of getting an API key, doing the setup process. It's okay. It just takes a little bit of time, like an hour or two to set it up. That's actually kind of like, if you're just wanting to do this, like the Pi notebook is there if you wanted to run through this. You'll spend a minute trying to get set up with Earth Engine before you actually like run anything. So Earth Engine is contained in Python in a really nice, solid package. It's got really good bindings and works really well. You can kind of ignore this cell. This is all of the authentication and initialization process that Earth Engine goes through. So it actually requires you to, and actually it might, okay, it's good. It requires you to stay authenticated to do any transactions with it, because if they didn't have a proper authentication process, it would constantly be getting DDoS, which actually happened a few months ago, where someone DDoSed the Google servers and killed Earth Engine for a little bit. So the authentication has to always be sustained for you to do any of these pulls, because you're talking about processing petabytes of data on a whim of like a couple of lines of code, and they have to constantly keep that together. This right here is a polygon which contains the proximity of Patrick F. Taylor, the building we're in right now. So defining this requires you to actually make a little boxed-in polygon if you want to do like a free draw polygon. So the best way to do this is to get on Google Maps and just find out where the points are that you want to draw, right? And then put those into a list of coordinates of like, I want a polygon that contains this place. After you have that, you can actually just make it into a little Earth Engine geometry. And the Earth Engine geometries are, again, actually proper GIS formatted data that's going to let you enclose some kind of area and then process and capture it. Does that make sense? So we're making a polygon with these individual points on a map and then capturing something with it. Now this is where we start to get into strings. And this is where Earth Engine gets to be like, you have to do it correctly or it just breaks. So this is actually the string that Earth Engine uses for the Sentinel-2 satellite that we talked about. It's called that because that's the actual name that the satellite uses for itself, is Copernicus space. And also, another fun thing about these satellites is that they have very similar qualities about them. Like, they have red, blue, and green data that they record, right? They all call themselves different things for what red, blue, and green is. And interestingly enough, red, blue, and green can be different things from one satellite to the next. So while I cut off my red at, say, 800 nanometers, you cut yours off at 780, we have two different kinds of reds, right? So there's actually some interesting synchronization issues you come up with when you want one red to be the same as another red. They aren't always the same. And then we're going to have a start date and an end date here. So what I'd hoped to accomplish with this was to capture an interesting time lapse of PFT from the time it was built, which I believe was around 2013, to when it was finished with a full renovation, so I believe it was 2017. So somewhere in that time frame. So scrolling down here. So yes, basically all of Earth Engine, because it has to be as universal as possible, everything's essentially string typed. So you pass in strings, it looks for it in its collection of data, and if those strings exist, you can match it to something like, here's a satellite and it has bands named this, so I can give you the data back. Because they have so many different sources and so many different data sets they have to deal with, this is really the best way to do it, rather than trying to really punch it into the API some kind of way. If you want to add a new satellite source, like if they launch a Landsat 10 or something, I don't know what they're going to call the bands, I don't know what they're going to call the satellite, or how the data is going to differ from the coordinates in this one to this one. So we're going to make everything strings and just make you know what you're supposed to put in there. And this is where the data sets becomes very useful, because it tells you all of this. So when you look over the dataset documentation, it starts to tell you about all of the different data sets they have, and there's a lot of them. And then we can go through the Sentinel data. I believe this is this one right here. So if you didn't have a reference guide like this, you would not be able to properly use Earth Engine. Thankfully, Earth Engine has really good documentation. So when I'm using things like this, I see that the name that this is different from the one I'm using. It's fine though. But we can see the name of this one is a certain Sentinel-2 processing, right? You have to have that name, and you just have to know what it's called. And then you can actually see all the information about the different bands that it has. So like before, I said that Earth Engine is in fact a 10-meter pixel size. It'll tell you, or sorry, it's Sentinel-2. It'll tell you the size of the pixels, and it'll give you information about the wavelengths too. So I can actually know what wavelength these things are operating at, and I can know like what is this band supposed to represent, right? So if I need to know the difference between red, green, and blue here, and then I have all these extra red bands. I have near infrared, shortwave infrared, which is a really high width wave. Shortwave infrared's quite hefty compared to our normal visual ones. I have all the information about what I need to know about like how big are these pixels. You'll notice all the pixels aren't the same size either. The water vapor pixels in the 900 range are 60 meters compared to the visual 10-meter ones. So all this information is relevant when you're trying to work out like how do I use this. This is all pertinent information to even get things to render correctly. Honestly, kind of hard to use if you're just lost as to how this is supposed to work at first. You have to do reference documentation and then go back and then type in strings back and forth. That's kind of the workflow you end up with. Okay. So we have these variables for what satellite is it, what do I want to capture. So I know from the reference document that this is the Sentinel-2 satellite, and I'm capturing the red, green, and blue of it. And I'm capturing it over these dates, which are in the year, month, day format, right here. Okay. And this is where Earth Engine gets to be really strong, because this is a few lines, and it's going to actually process petabytes of data through these few lines. So when you go through the workflow, I'm going to capture from the image collection of Sentinel-2, and now this is where the server-side transaction starts. So I open it with calling Earth Engine and starting some transaction on the image collection for Sentinel-2. At this point, the server has said, okay, I want the entire collection of Sentinel-2. So it's going to say that all of these are valid things you can use. How much data does Sentinel-2 have? A lot. So it's going to kind of store references to what's still valid. Essentially, when you think of like a database transaction, right? Like I'm going to retrieve these things, I'm going to filter it down to these things until I get the final result. That's sort of what we're doing here. Then we're filtering the dates out to say, okay, I want it from this date to this date. So now I have all my records, and I have the fields limited down to those few years that I want to find. And then I'm filtering on my geometry. So what was I capturing before this? Well, I had all the Sentinel-2 pictures in a few years across the entire Earth. So I had years of pictures of the Earth for every 5 days. So that's essentially capturing like 140 weeks of photos of the entire Earth. That's a lot of data, right? So then we're going to filter it to the PFT geometry specifically. So now we've taken it from the entire Earth over those several years down to a small box that's the size of a building. So this is a very important step in the filtering process, because trying to actually raster and render like the full Earth is hard, and it's a lot of data to even get big pixels. So this one I kind of put on a different line just for the sake of like showing you at this point we have PFT, but what we have is actually all the bands for PFT. So that means I have all of the aerosol and the shortwave infrared data and everything else in here. If I wanted to capture interesting things like that, I would use it. Now, actually, something I think I skipped over earlier too is the urban expansion research that's done with Earth Engine 2. So this is a time where just the visual data can be really useful. Sometimes the infrared data is super useful too in the cities. But if you want to track how cities are changing in size, or how the population is shifting through a city, and track how that affects the wildlife and affects the movement of people through the city, that's actually an active research area where people are capturing how are cities changing and expanding over the past 30-ish years, from the 90s especially, and how is it affecting the earth, how is it affecting the movement of people, how do people use the city, stuff like that. There's actually really interesting research in like designs of cities, like how do you expand cities certain ways. If you want an example of how to not design and expand your city, you can look at Baton Rouge, because it's terrible. But there's a lot of research on those kinds of things. This is probably the most powerful Sentinel-2 specific line. So you can actually filter using Earth Engine. You can go look for a property on every single one of these images and see if the cloudy pixel percentage is below 20. At that point, you know that you actually have a pretty clear image, right? So I have a clearish image, and I want to use that one because out of all the images I have of the building, there might be a lot of them that are like full clouds. I mean, you see the clouds do full coverage for days at a time. Sentinel-2 captures a lot of white pictures because it's just almost entirely clouds. It's kind of hard to avoid doing it. So this is actually filtering it down from multiple images to a single image. Now I was going to try and make a GIF out of this, and it went badly for a lot of reasons. We'll look at why. But if I take all of the images, I can actually find the mean of each of them, and this is a pixel by pixel operation. So keep in mind, this is still on the server side. So every time I'm going between these steps, it's saving a reference of what my current object looks like, my current records, and then every time I go to a next step, it's modifying those records that I have saved through my authenticated connection with it. So right here, this is actually going through every pixel in these images, and it's taking the mean of each of them. So over several years, I would have like a bunch of data, and I would collapse it down to a single pixel based on the mean for each one. So I would get the clearest view of what it looks like on average, right? Every pixel on average gives me a clear view of what the whole thing looks like on average. And then clipping that to the PFT geometry again. Reason being that I do have the bounds for PFT, but I want to actually secure it to those bounds now. Earth Engine is a little bit finicky about how it does bounds, so at a certain point you have to actually like cut it on its edges to make sure it's properly seated. It's quite odd. And a little bit more domain knowledge about how it works. Sentinel-2 images are shipped and processed from the government and kept in the Google this way, with their numbers essentially in like full integers, but they're supposed to be cut to floating points. So you have to divide every pixel in the image by the number 10,000 to get it in the proper range of what it's supposed to be like from like 0 to 255. So that's weird domain knowledge about what you have to do to process it to make it look correct. Otherwise, it can totally screw it up. It is really powerful to have 5 lines, and it does petabytes of processing in seconds. Any questions about like this workflow?
Do you know what kind of database you use like what kind of API are you using? What kind of database is on it?
So it is REST. I'm trying to think about what they're doing for the database on the back, but Google also has a lot of custom structures because they have custom file systems as well. So it might be that they're doing GFS to do this, the Google file system. I'm not really too sure. But I imagine with the way that they distribute and they do redundancy, it's probably a custom system where they're distributing across like a distributed database system. Because they do that for a lot of their stuff, like distributed databasing. So I imagine it's something like that. That's something I think I used to know and I don't know anymore. Because you get curious about how they do it, but it might also be a little bit of trade secret.
So this is not like something that's like essentially just Rust or like not a lot of dynamic data. It's very static, but very large.
Yeah, and that leads you to think about like optimizations too, because they are updating consistently, but there has to be ways to optimize on all these static tabs of data that you're going through, right? And I don't think they publicly disclose anything about how they optimize this. there's probably a lot they're doing, because this operation, I did all these lines in one. To go from processing all the Sentinel-2 data that exists to getting one image takes less than a second, right? So it has to be high levels of processing that they're doing to optimize this out, right? And then literally, it takes less than a second to go from several petabytes to one image. It's insanely fast how they do it. I have no idea how they do that, but it works. So now, I've taken every single record of Sentinel-2, and I've filtered it down from a geotiff in a JSON format into a geotiff for just the one image. And this was, this was trillions of lines at the start of it, so the referencing is super fast to get it down. You can see what the image looks like in its geotiff format when we JSON it up. And we'll see that there's this Earth Engine image which has been created, which has history too of how it's constructed. It knows things about its coordinates, and it knows things about all of the way that it was created, basically. So I can actually parse this and find out a lot about it. I know what kind of satellite it is, and I know what bands I'm using all through this. It's a lot of data to process that quickly. It's incredibly fast. Any questions about that? Really cool. Where am I at on time, actually? 8:24. I start talking about these things, I think I just start having fun. I kind of forget exactly why I was talking about anything. So this one, this is kind of interesting. I'm not going to explain this. This is a processing parameter to try and actually rasterize this. So right now I have a record that I've created out of all of this, and now I'm going to rasterize it. So I'm going to take a set of parameters, and I actually have to put in sometimes you want to modify the coordinate system and stuff like that, so you have to actually know what coordinate system a certain satellite uses. Here in the West, we only have a few coordinate systems, but depending on what country you're talking about, they might actually record and store their data differently. So coordinate systems are not universal. There's a lot of them. And now it's going to actually rasterize this for me on server side and give me a URL to it. And that again takes less than a second for it to go through the rasterization and do it. Actually, it takes a couple of seconds, because when you open it, it lags a second and then it comes in. It takes about 2 seconds or so for it to rasterize when you finally do it. All right. What do you think this is going to look like?
I think because you average everything, it's going to be even gray.
That's an interesting observation. It's actually incredibly blurry. So I don't know how to do math. You know how long this building is? You know how big a 10-meter pixel is? So I wasn't thinking about this at first, but 10 meters is way too big to capture the quality of things when I'm trying to average it and take a long time frame. So it's pretty ugly because of that. Now what I could try to do, and actually I just thought about this too, is that I might be able to make it look more coherent if I put it in a small time range. Because doing it over a larger time range just didn't work out, but we'll see if I do mid 17, right? So I'm going to change these parameters. I'm going to reprocess my image. I'm going to print the new image, again, fast. And then hit this again. And we'll see the lag time on this one, actually, when I open it. And, yeah, it's a little bit better, I guess. It looks like a building, I guess. So actually, this is a real concern when you're talking about urban data. So you can hardly use satellites to do urban sprawl recording. Reason being, a car inside of a 10-meter pixel that looks like nothing, right? It's like a car inside of that size is really terrible. That's why they typically stick to doing very specialized data over short time frames so they can capture this kind of stuff. This is in fact the building, though. I sort of verified it. I mean, I did it correctly, I think. So it is the building. And I changed it around to see how it would work. So then I tried this to capture the campus geometry, and actually now this is set to 2017. So This is the campus, like Tiger Stadium to here-ish to the lake. So we're going to capture the campus geometry now, which is this polygon that I drew around the campus. We're going to filter this. And again, really fast to filter out the entire campus. And then we're going to try to export this one as well. So I'm using about the same settings as previous. And now let's open up the campus picture. Look at that. That one actually looks like a city. Look at that. Okay. So the processing of, like, I want to capture all of this and I want to get these pixels at certain sizes can be really hard. It's also really hard to obey limits. Google Earth Engine will not let you immediately kill your computer by exporting like 200 or 300 gigabyte rasters. It won't let you do that. It has a maximum pixel size to it. So you have to be really careful about like trying to get them in bounds. That's where Earth Engine becomes super useful too, is I can set it to a sort of pragmatically record chunks and clusters, right? And after you record those chunks, piece after piece, you can stitch them together into larger images, which is the typical workflow you use. I'm good now. Thanks.
You have something you want to announce? I know the crowd kind of got a little lighter, but I'm going to introduce you.
Oh, I'm Jessica. I'm one of the organizers of the Google Developer Group in Baton Rouge. Real quick, students are allowed to come to our events too. We're very beginner friendly, so if you're interested in coming to anything, you can find us on Meetup or gdg.community.dev. We don't have our next event planned quite yet, but we do have a weekly study group. We meet at Barnes & Noble Sundays at 2. We study and we have co-work. So, but actually what I'm here today is that I'm helping organize a conference actually at Patrick Taylor on March 18th. It's SQL Saturday, the BI edition. So it's going to be data and analytics. It's a free conference, so if any of y'all are interested in that, I got a QR code. You can scan it. I'll just leave it over there and register. Like I said, it's free. March 18th is Saturday. And that's about it. And also, I'm in charge of volunteers. So if anyone's interested in volunteering, you can come by me or get in touch with him and his team.
And I'll put y'all together.
I will leave this.
Thank you.
You're
Oh
welcome.
yeah, I forgot the barcode. I'm actually gonna, if this is okay with you, I'm not only gonna share with them. I'm gonna find a place to put it on
Okay,
campus.
yeah, that works.
All right. Thank you.
You're welcome.
I know we're not doing like any type of Kahoot or something, but I do have swag, and so like 1, 2, 3, 4, 5, 6, 7, 8. I want to pick a number between 1 and 10, and then the closest 3 people get it in that order. So
Use
I'm picking a number.
randomnumber.com to make it fair.
Or actually, I lied. It's a number 1 through 50. That would be more accurate.
1 through 50?
Yeah, because that's how we could get a first, second, and third. You know what I mean? So 1 through 50, I got a number in my head.
Oh, okay.
Use random.
Can you
Hold
tell
up.
what the number is?
Let me get
Yeah,
random.
let's use
I already have the
Random
number.
random number generator.
You're gonna do the random number generator? Okay, fine.
Make it fair. Okay.
Yeah,
Alright,
number 1 through 50, and then we'll go in order.
I'll have to like hack your challenge and find what seed
Do
was
I?
used.
Did you win a challenge?
All right.
Yeah, it was like the first.
How should I do this? Should I generate the number first?
You generate the number, yeah, and then everyone gets. So, what's your number? 25.
Oh, smart.
What's your number? 24. What's your number?
Okay, I'm gonna use like a mean strategy, 37.
Okay. What's your number?
It's 1 through 50.
Yeah.
I'm gonna do 38.
Okay. Alright, what's your number? 27? You're not in it. What's your number, man?
It was 1 actually.
Whoa!
Legitimately.
Wait, so in that order, hold on. So 1, that's first, and then we had 15, and then you had another, so you had 30. 24. Dang. Alright. So this is yours. This is the first place one. And this is yours. And then you can grab the stickers off that ladder.
Awesome. There you go. Awesome.
Alright, thank you guys for coming.
Yeah, thank you guys so much for coming and those that stayed with us throughout the night. It was a good. It was a good night.
We know we went a little over, but
No, it was a good night.
Thank you guys. We appreciate it for your work.
we're gonna try to have some like, so like this is like our biggest event. We were just trying something new. This is the first time we did something like this. We're probably gonna shift back now because this is kind of overwhelming for us. So like we're probably gonna shift back to like having like our 1-hour workshop on a new topic. So just stay updated on our Discord because we always post on that.